Mm-mm. Mm. Mm-mm. Mm. Mm-mm. Mm-mm. This this is why you don't let front-end JavaScript developers write Rust, because you. And who uses return? Who uses return in Rust? Who the fuck does that? You don't have to do that. Hey, Dave, thank you for the 38 months. Is he Benny's solution? Nah, it's probably shit. Probably shit. It's in this thread. Nice indents, Benny. What's this? You just put a semicolon on the same line as another line? Classic Benny. Classic fucking Benny. Yeah, more like take a Benadryl, because that's what the CPU is going to be doing when running this code. Hey-oh! Woo! Julian C., thank you so much for the 8 months. Roasted. Yeah, let's put on Origin. Origin's so fucking good. All right, let's see. Okay, so today we're gonna be doing Advent of Code. I've never done Advent of Code before because I'm not a programming nerd like all you programming nerds. JC Code, thank you so much for the 2 months. Hell yeah. Holy shit. Oh, 34 months from Above Siegel. Oh, there we go. Yeah. Yeah. Thank you for supporting all of the content that's being produced. If you haven't been seeing any content, then maybe you should be subscribed to my OnlyFans. Torabaka, thank you so much for the 31 months. Hell yeah. Is Advent of Code, does it get harder every day? I have no idea. I've never done it before. This is the first time I've opened it. Oh, Benny missed the roast. Oh, Benny missed the roast. It should get harder, but it's been pretty easy this year. Yeah, I mean, this looks really, really easy. But that's fun. I've got a friend learning programming, and I recommended that they give this a whirl. Smooth Hacker, thank you for the 25 months. Feel like I should get Gamozo Inc. shares. Gamozo Inc. That'd be a terrible company name. Who would name their company Gamozo Inc.? Who puts incorporated in their company name? I write only Python. Maybe I try for fun. Gamzo LLC. Hey, converter, how's it going? It's happening. It's happening. Yeah, we saw Benny's solution with the shitty, underscore semi there. Yeah, and really just the perf. The joke that you missed, Benny, is that you should take a Benadryl because that's what your CPU is going to be doing when it runs this code. It made more sense when it was the first time I said it, I guess. Ego, thank you so much for the 8 months, hell yeah. Oh. Do Advent and CUDA for real perf? I don't have any GPUs that are good. I don't know how to do GPU. Do I look like someone who knows how to do GPU dev? I don't know how to do GPU dev. Mr. Synaxter. The screenshot rendering tool put the in the next line, not me. Oh, okay, Benny. Okay. Okay. You absolutely look like someone who knows how to do GPU dev. I really do want to get a nice GPU. That is kind of my plan at some point, is to get some CPU, GPU sticks to put in my PCI slots, but I don't have any reason to get them yet. So I got to come up with a reason first. I'm sure Benny runs Rust format after every typed word. Pff, yeah, exactly. You should upgrade for Dragonflight. I have a 3090. It's just in my gaming box. Saving up my points for a Rust GPU driver. You Rust in this year. No, I do C. I'm a C developer now. No, I'm now a Java developer. This is going to be a Java stream because we want enterprise grade solutions to advent of code. Where's the close button? Change stream tags then. Has everyone been behaving? Code factory method. Vectorized emulation, but more parallel. Yes. Java runs on 3 billion devices. That's 3 billion devices that my Java bugs can land in. That was always my favorite thing, because they started putting that in the installer in like the late 2000s, early 2010s, and that's when Java was really getting shit on. And it was like, you're just advertising how convenient this is to get code running on people's machines. But what was it, like 3 years since last stream? Yeah, I haven't streamed since COVID started. GPT sub. Like, are you saying that you're submissive? What are you saying? Are you saying Bitcode? Thank you for the 32 months, though. That's a good power of 2. The Marsharena. Maringa. Okay. Chat GPT is spooky. Yeah, it's definitely spooky. Because it means that instead of the top 10 results from Google being fucking AI generated advertisement sites, they're gonna be the top 50. And can't wait for that. Oh, Geek Pirate, gracias para broken español, para los 10,000 ode. Y es muy fácil para mí hablo español. Sí. Bienvenidos a la stream. Y yeah. Bien español aprobado. Gracias. Gracias, mi amigo. Es muy bien. Can't let your Spanish get rusty. I've been thinking about trying to pick up a new language. Are you okay? Are you okay? Oh, we got a hype train going? Oh, it's complete? The hype train ended? Oh. Well, that's sad. Okay. Well, I guess we're gonna have to write code then. Gamozo-lang? I do want to write Gamozo-lang. There is a Gamlang. It's on GitHub. You can get Gamlang on GitHub. It's a great language. Highly recommend it. I need to pump my voice through my headphones because I am really muffled right now and I'm probably talking weirdly. Did I hear French in there? Baguette. Yes, I get the cigarette and put it in my baguette. Mamma mia, that's Italian. I don't know. Paris, I surrender. Ha ha. England save us from the Germans. I don't know. I don't. I don't really know how French goes. Bonjour. Yes, bonjour. Uh. Uh. Multicultural. I like it. Yes. I know so much about France. They have an Eiffel Tower. They paint things there. And really it. I don't know. So today we're gonna be looking at advent of code. Um Mainly because these solutions by like Primogen, this is cringe. This is really cringe. The one by Benny is also really cringe. Um this one's not even written in Rust, so that's really cringe. Sure, that has a lot of perf. Yeah. So that's what we're gonna look at today. Um, so we're gonna play around with that. We're gonna probably get mad at LVM code gen because LVM seems to not be able to produce code anymore. So yeah, we're just gonna give this a go. So the way to get to your stream is to tweet cringe code. Shit. Shit. I honestly wouldn't have streamt today if it weren't for this absolute garbage code. Raw assembler, here we go. It's called assembly, Geek Pirate, not assembler. Nerd sniped. Yeah, I don't know. I mean, this is not a very interesting of a problem. I thought advent of code was like hardcore shit, but this is like I didn't know like how I thought advent of code was like code golf. I didn't know it was like this, which this is honestly way cooler in the fact that like this actually is fun problems because they're problems that can be solved. It's a speed competition. Ah, shit. Chat, don't start the timer until we start or something. Got to solve it faster than other people. Ah. You need to write the code faster or your code needs to perform faster? You need to write an actual assembler though to compile your assembly code because fuck LVM. Yeah, pretty accurate. You need to write the code faster? Oh, god damn it. Yeah, okay. Yep, so this is then designed for big tech developers. The people who don't know how to code, but they can just churn things out really fast so they can suck their boss's dick faster. That sort of thing. I'm kidding. I'm kidding, chat. I'm kidding, chat. Infinite linked list interviews pauses the need for speed. It was not a joke. So we're gonna over-engineer this problem. We're gonna do a couple things, and then we're gonna talk about what the stream goals are for 2023. Okay? How does that sound? All right. Cool. I'm glad. Horizon RSUs. Yeah. How are those tech RSUs looking right now? Woo! Woo! Scam 2023. I think you need to use Java. Yeah, I probably should use some Java. Stream goals exist. I mean, existing's not easy. Living that cash compensation contractor life, yeah. Yeah, give me that straight cash. Let's see. Okay. Cash is king. All right. We need a food stream. Someone did donate for me to cook on stream, and then I never did it. Kinda dick move. Cook in a hot tub. Like sous vide. Like turn my hot tub to like 135 and then get in the hot tub with like a steak. Nightshade, I said it first. I said it first, Nightshade. Ha! Ha ha! Ha! Ha ha! Ha! Fuck! Hack the fridge? That would be fun. Now, I've been thinking about doing more physical things. I think it's time for me to build the electron microscope I've wanted to build for a while. So I gotta buy a lathe and a mill and learn how to use them. And then I want to build my car. And then yeah. 10-hour smoker stream? Oh, big vapes. Big vapes. Ask John McMaster. McMaster of McMaster car fame? He's definitely made an X-ray. Yeah, I want to make an X-ray as well. I want to make a focused ion beam. I want to make a... well, the electron microscope that I want to write, I think is going to be really exotic. What I want to do is I want to make an electron microscope with multiple beams in it. And I don't know if that's possible. Like, I don't know if physically you can separate the coils enough to not affect the other beams. But I want to have, like, 4 different beams in the same vacuum chamber. And I'm hoping that what I could do is I could accelerate the beams to different electron volt thresholds. And then hopefully on the detector, I could detect which beam was the source of the of that electron based on the energy. I don't know. Obviously, it might lose some energy when it like hits and bounces off the material. But I feel like there is probably signal there. Yeah, are we going to be fighting like noise floors and we're going to have to do a lot of crazy shit to like try and extract that signal? Yes. But that's what I really want to do. I'm going to write like a completely computer-controlled, non-rastering electron microscope where we can do like arbitrary patterns and have multiple beams that like fixate on specific areas and stay on those areas for extended periods of time. There's a lot of like really, really, really hard problems there that I don't understand. I think we would have to get into like learning some of the math and physics behind it, and probably doing simulations of the like beams to basically try to theory craft like the best way to design it. So obviously it's a large physical project, but it's also a shit ton of code to like. I want to have an emulator for the physical microscope that I build. Not a theoretical microscope, but like I want to mathematically model the properties of the one that I build such that I can like focus it in software and do really, really, really sensitive like fine-tuning and signal analysis off it. So jack up the ohms, blow those chunky rips. Is that a vape joke? Let's get physical. Are you figuring out more ways to defeat area gap systems? My plan is to get arbitrary microcode execution on any processor that I want. Just ask ChatGPT to write the code for the electron microscope. There it is. There it is. Can't wait for it to just copy paste that right off Stack Overflow. At least it will put comments in the Stack Overflow post. So that's good. ChatGPT does look impressive, but that's about it. To be frank, what a real dev would do too. Yeah. Well, they wouldn't comment their code. So that's how you can tell if it's Chat GPT generated. If I were like a large company like a Microsoft, what I would do is I would look for who is committing, like whose comments just shot up through the roof on their code that they're pushing, and I would immediately investigate them for just using Chat GPT for their work. Obviously, it doesn't actually matter if it gets the job done. I think it's ridiculous that people get punished for having multiple jobs when the companies cannot detect that they're working multiple jobs through their output. Rewrite the code without comments. Somewhere out there, there's people who probably think comments slow down code because they like add space between the lines or something. I don't know. All right, chat. Are we gonna talk about the bookmark bar? What do you mean? Comments equals nops. Would comments slow down code in an interpreted language? That really depends. In theory, an interpreted language should still like generate an AST or like parse the document and like tokenize it. And it shouldn't be like walking the comment tokens as part of the script execution, but it could. There's no reason it couldn't. The Primogen subscribed for 6 months and said, "Suck it." I think I know what that means. I think that means we got to do some QOP. Okay. I don't know how to play this. It's just Q and W and OP. So what do I want to like? Which leg is which? How do I know which leg is which? I like how they have the space. Okay. I don't know which leg is which. Whoa, shit. Oh! Okay. Outsides and insides go together? Okay. Oh, that makes it really easy then. Okay, this is really easy. Okay, that's not good. Wait, can I like inchworm it? Oh, come on. It says 1.6 meters at the top. Can't see the screen. Ha ha ha, XD. Professional streamer. Okay, this is I can't even really feel what I'm doing. So Q makes the right thigh go up. Wait, does it make it go up or down? Q is up, W is wait. This shit needs to be tasked. So I'm thinking about writing an emulator for this game. Okay, this is shit. I like legitimately like don't even feel what the mechanic is here. Woo! Oh, I almost did a flip. It takes a bit. Yeah. Yeah, this is this it? No, that's flash shit. Can I prettify this? You can't prettify? You can prettify in Firefox. Oh, wait, that did it. How the fuck is this 21,000 lines of code? Oh, it's probably got some libraries in it. Best place to ask you some questions? In chat. In chat. That's the best place. Okay. Game over text. Game. Okay. Is this Evanescence after she went psycho? She went psycho? I'm not familiar. This is Evanescence from 1999. So this is like probably even before that. Probably before. This is before she's like done almost anything. Is this modifiable? Can I not modify this script right here? Does this breakpoint get hit? No, okay. Let's see. Can I even hit breakpoints here? Oh, yeah, I can. Okay. Good. I don't know what this shit is. Where am I hitting? I'm hitting there. Am I hitting here? $63. There's the score text. And then it runs this every time. Bevel shader. Do I have to put a breakpoint on this to be able to hit it? What's end game? This dot end game? This dot game ended. Can you not change these? What? 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 Can you not modify these? Oh, you can. Okay. Ended true. And then I want, what else? If pause is not equal to 0. Fallen is false. Jump landed? Need to do that as well. Oh, do I have to now? What do I do here? Okay, it seems this breaks the game. All right, let's try it again. End game. This is called. Isn't it called on game ended? Oh, jump landed and game ended. Okay. Click to begin. Okay. Pause this. Go here. Okay. Game ended. True. And jump landed. True. Okay. Do I have to... What? Is there another condition? Oh, game ended 0? Well, now I'm just really confused. Yeah, let's go! Woo! Yeah, take that, Primogen. Take that, Primogen. Easy. Easy. Let's just put that into Primogen's Discord quick. Okay, we'll go into here. Post this. Okay. There you go. All right. Let's fucking go. The software equivalent of participation trophy. Look at this. Let's see. Got some speed. He got some speed here. Oh, was I in chat? Was I in chat here? Was I watching this? I remember I bet on you completing this once and I lost my 10.5 seconds. That's okay. That's pretty pog. How are you running so fast? How are you doing that? How? A little bit of a blunder at 90. But pretty good. That's pretty damn good. That's what a What about this? Is this not a national hero too? What about this? This looks good. Can you full screen this? Is there a way to do that? Is this like a Flash thing where you can get this full screen? That's always my favorite thing. Whenever on like Flash game websites back in the day, you'd find like the .swift file and you'd go directly to it so you get it in full screen. That was always really pog. Oh, there's got to be a way. So I'm really curious how complex the math is in this game. Zoom in. And that blurs it though. Okay, work time. Yes, you're on. You're probably the fastest person ever to get national hero. So I really want to make a task for this at some point. I don't know how complex the physics are. I also don't know if they're using 32-bit floats, 64-bit floats, or if they're using like actual big int float sort of things. But hopefully we could, like, to the bit, reproduce the exact physics of this game in Rust, and then like look for exploits and weird clips and glitches and like boosts and impulse stuff. So probably just normal JS floats, so doubles. Yeah. So I don't know how complex this is. I don't know why it looks like so much code. Like, I don't know how this is 20,000 lines of code. I would imagine it should be like 300 lines of code. So hopefully there's just a lot of like duplicate stuff and maybe a library in here that's not necessary. Maybe a lot of this is tweening and rendering. That doesn't matter. All we care about is the physics engine. We care about collisions and the physics engine. We don't care about display and rendering and visuals unless it's actually like rendering it and then using the pixels to determine collision. Doubtful. So what we really want to do is just the core physics of this game so that we can fuzz it headless and look for crazy strategies and beat Primogen's time. All right. So, it's probably auto-translated from Flash. Yeah, that could be it as well. I saw like some tween references. So, that's kind of interesting, to be honest. What are those bookmarks? What bookmarks? It's all 2 to the 53 minus 1 for ints. Wait, are ints doubles in JavaScript? Wow. Yeah, okay, that's... Okay, let's go for a little bit of... Could we do some deep cuts? Um, is this a queue up fuzzing stream now? At some point. Not right now, okay? Relax. 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 If you don't use bitwise stuff, then they get truncated to 32-bit ints. Oh, cringe. Yeah. Okay, so what we have to do is we have to beat this. So what I need everyone to do is go to this URL and give me your input. Okay? So go get your input and then give me your input. This is the first thing that we're gonna do. So the goal is to solve this advent of code. Music is a tad... You're a tad loud. You're a tad loud. Bitch. Okay. So. Alright. Got one. Okay. Sweet. Not a dick pic. Alright. That's good. That's good. Good to know. Good to know. Alright. Got a buff seagulls. There we go. What is paste bunny? Is this paste bin for furries? What's the little animal on it? Paste.sh. I love how everyone has a different paste. Okay. Okay. All right. Sweet. Gotten a lot of them. Hope you have JS disabled. What is this paste.rs? How does it have a 3-letter thing? How does it use 3 letters? Are they like really short-lived? Okay, I've got all those opened. All right. All right, chat. So let's go in and we're going to read the prompt for today's advent of code. All right. Thank you, Julian. I think I have all these open so far. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. Oh, fuck me. I'm missing one. I'm missing one. Ah, dick. PLL, CIFA, CTM, JO4. Do I have I have JO4. DPN, HZ, non. Oh, shout out to Manatee for getting non. Paste.sh, I have that. 1, 2, 3, 4, 5, 6, 7, 8, 9. I had 9 open the whole time. I'm an idiot. Okay, so, how do I... Is this making more bass? Am I getting more bass? Is this more bass? Is this like a good voice now? Did I do more bass or did I add... Did I just add some random thing? Okay. You now have a radio voice. Okay. The preparation. Okay. Day 6. Tuning trouble. The preparations are finally complete. You and the elves leave camp on foot and begin to make your way toward the Star Fruit Grove. As you move through the dense undergrowth, one of the elves gives you a handheld device. He says that it has many fancy features, but the most important one to set up right now is the communication system. However, because he's heard you have significant experience dealing with signal-based systems, he convinced the other elves that it would be okay to give you one of their give you their one malfunctioning device. Surely you'll have no problem fixing it. As if inspired by comedic timing, the device emits a few colorful sparks. To be able to communicate with the elves, the device needs to lock onto their signal. The signal is a series of seemingly random characters that the device receives one at a time. To fix the communication system, you need to add a subroutine to the device that detects a start of packet marker in the data stream. In the protocol being used by the elves, the start of a packet is indicated by a sequence of 4 characters that are all different. The device will send your subroutine a data stream buffer, your puzzle input, and your subroutine needs to identify the first position where the 4 most recently received characters were all different. Specifically, it needs to report the number of characters from the beginning of the buffer to the end of the first such 4-character marker. Sounds like a vibrator. All right. ZOB. Did I open ZOB? I don't know if I opened ZOB. Did I get Y1? I got Y1, the Yowie. All right. All right. So, basically what we need to do is we need to detect 4 repeating characters. So for example, this one, or we need to find 4 characters with no repeated characters in that 4-character window. So in this case, example 1, that has a repeating character because B has repeated. So then we'll go to the next one. We'll see that there is no repetition of any letter, which means that the index afterwards, the index of the P, which is 5. Same for this and this and this. It's a pretty simple puzzle, not super complex, but what we're going to do is we're going to make the Primogen and Benny look like, you know, Primogen and Benny's. So, what we're going to do is we're going to first look at what dumbass shit Primogen thought was a good idea. So, I have my own input in here. And what we're going to do is we're going to copy what Primogen did real quick. And the way that we're going to do this is by just doing bitwise option usize. I'm going to type it literally as it is. Return prod as bytes Windows 14 position move set let mute data U32 is 0 for ref C and set let prev is data state data or equals 1 shift C minus BA. If prev is data, return false. Return true. And that is what the Primogen wrote. So let's first see if it does shit. Prod as bytes. Oh, he pulled it in as a string. Yeah, that's a Java dev for you. Okay, and then we'll just call bitwise. Just call bitwise. And that's going to return the position of that. 2275. I have no idea if that's the correct solution. So let's write the naive solution quick. Let's write the big tech interview question that they use to determine if you're worth 100K or 800K, and no other questions matter for that. So let's look at function. Let's just do naive. And we're going to return an option usize. I'm going to do the same type beat as Primogen, but we're going to do this way shittier. And we're going to actually do it, let's do Windows 4. And then we're going to do position. And what we're going to do is we're just going to make this really, really simple. And we're just going to say if x0 is equal to x1 and x1 is equal to x2 and x2 is equal to x3. Just that. And technically not equal. If that's not equal to x1 and x1's not equal to x2, x2 is not equal to x3, than that. There you go. Okay, there's the naive implementation. Let's see if that matches. Not correct. Oh yeah, this is technically not correct. This is not correct at all. So, if that's not equal to that, yeah, I need to look for repeating characters, so we can do that even easier. What we're gonna do is, how do we actually want to do this? Not correct. Fucking rude. Mute. Here, we're gonna do it this way. Make a set and check its length. Yeah, fuck yeah, that's what we're gonna do. I like that. So this will be off by 4. Ah, fucking. Oh, whoops. Okay. Okay, what am I doing now? Oh, Jesus Christ. God damn it, I'm an idiot. Really? Wait. Wait, is this wrong? Isn't it you just look for four bytes? What? Isn't that... I thought it was 4 bytes, not 14. Was it actually 14? 4 characters that are all different. Oh, there's a part 2? How do I get to part 2? Do I just have to solve it first? Shit. Is it the same input? 14 distinct characters rather than 4? Is this the same input? HRBBJ? Yes. Okay, good. Okay. So now we just do this. Okay. Oh, so his was wrong as well where it didn't add 4. But that doesn't matter because that's a constant time operation you can do in post. So it doesn't really matter. Did you like my part 1? Did you like how I just manually added 4 to it? Okay, yeah, so Primogen solution is absolute garbage. Yeah, so let's now do some benchmarks. So, first let's grab everyone's inputs. How do I make a random file name? Can I do like OpenSSL rand base 64 8? That'll put equals in them. That's fine. Whatever. I don't give okay, so this is 1. Oh, don't be a dick. Okay, is there a better way? Can I encode it somewhere else? Make temp? The fuck is this? Can I do it in this path? Hey! Oops. All right, checkmate atheists. Decryption failed. One of the pastes I couldn't get. One of the paste bins didn't work because decryption failed because I got a virus. Justice EX, thank you so much for the something. I don't know. I don't have chat open right now. Thank you so much. Does that look good? One, two, three, four, five, six, 7, 12. Do I need more inputs? All inputs are appreciated. Let me grab mine. Let's see if anyone scammed me by sending an extra. Oh, I got scammed! Someone scammed me! Fuck! That or I made a copy-paste error. I think I got scammed. Thank you, everyone, for all the inputs. Your input is very valuable. I think all those are unique. Actually streaming in 4K? Fuck yeah. Technically, it's not 4K. It's 1080p upscaled, but it makes the colors look good. We did a long stream about why I stream in 4K. It's a pretty stupidly complex reason. But TLDR, it tricks the encoder into not losing color information when looking at text. Okay, I think that's all of them. I'm sorry if I missed anyone's. They came in pretty fast. Thank you so much. They all do look different, which is fantastic. So now let's remove prod. Oh no, we deleted prod. Okay, so now what we're gonna do is we're gonna start determining effectively. We're gonna go through all the inputs. For inputs in let mute inputs is vec news. So we're gonna load all the inputs in from the disk, and we'll just do standard fs read dir inputs dot unwrap. Let in path is int dot unwrap dot path, and then we'll do standard fs read path dot unwrap. And then we'll do inputs. Push this dot trim. X inputs. Something like that. That's a decent start. A 4K stream. That's on my laptop's an afterburner. Yeah. Is there a reason you didn't use Criterion? What's this? Oh, because I don't use third-party depths. Oh, trim won't work on that. That's fine. Let's do this. Okay. Int trim as bytes. Oh, you piece of shit. Really, Ross? There you go. Okay, because I think if I don't trim, they should have new lines on the end of those files. Well, probably not if I do read to string. Nope, it does. It has a new line. So we're going to rip off that new line. That should give us the raw inputs. And then let's do this for inputs. Println int.len. Wow. Okay. Good. That is great information. Every single one of them is 4,095 exactly. So that is an assumption that we are going to make with our code. That is fantastical tentacles. Okay, let's do frequency analysis of those as well. Fuck. Same character sets? Same character sets? Yeah, let's fucking go! Let's go! Let's fucking go! Same character sets, not the full alphabet. That's another thing that we can use to our advantage. Let's go. Maybe. I don't know. It's hard to say if that will help us at all. It theoretically could. I should verify that they're actually the same character sets. This can just be insert. They do look semi-uniform. Oh, baby, talk dirty to me. That's what I like to see in my code. Fuck. And those are all identical character sets. Woo! Beautiful. Beautiful. What's the strat here? No idea yet. I still don't know. I am learning the constraints of the input so I can overfit my solution to the problem. So we know they're 4,095, which is fantastic. So 4,095 means that we will be able to use a static sized array, and that means we'll be able to avoid all length checks. We'll be able to really make that simpler, and we'll be able to unroll the entire operation, so we won't actually have to determine like what the true lengths are there. So that's gonna be pretty good, I think. So let's first benchmark how fast the cringeagens implementation is. Let's just do prod. Both of these took slices. Primogens he did as bytes, if I'm not mistaken. And we know that these are identical, so we'll just we'll keep the naive one, because I don't trust Primogens. Data is, I'm guessing that's a stir, or prod. And then naive, we'll say prod is a slice of bytes. Okay, so, let's see. So this is the information we want to know. This is the set. And then let's also print those in hexadecimal. Because that just might be nice to visually see kind of what their bit patterns are. And it's this. All right. Okay. All right. So we can get rid of all this code, that code, and then we'll do for in inputs. And then we'll do... actually, we'll just make Primogens take a fucking byte array so we can actually use it in a reasonable manner. And let's see. Let's see. Oh, yeah, you can't really see the bottom side of that terminal. That's my bad. I forgot I changed my layout a smidgen. Okay, here we go. Okay. So this is load the inputs. The quality of this code that loads the inputs doesn't matter. And then this is just going to be tests. And we'll do println. Let naive. Naive solution is equal to naive. inputs. Let's primogen solution, and we'll just say this is prime. By prime, I mean shit. Just kidding, primogen, you're amazing. Love you. Okay, and then let's just do refs on those bad boppers. Okay, and then we'll assert those are the same. Beautiful. So that worked on all of them. Okay, so let's do for blah in 0 to 1000. So what do we want to optimize for? I guess we want to optimize for average time to find the solution for all the inputs. Yeah, that's what we want to do. So we're gonna do for each input, input ID. Oh yeah, and let's insert these into a hash map of their name. And that's gonna be a 2-stir. Okay. And then we'll put that in a B tree map. Use standard collections, B tree map. So we'll use a B tree map for that. We'll do this for a bit and then run that. This is gonna be the yeah, input ID. Fuck it. I'm gonna do a vector. No. We're gonna do a B tree map. And then we're going to B tree map. And then we're gonna... I'll bench yours too, Benny. I'll grab it in a second. Forgot. Yeah, I kind of want that info. Sure, we'll do it for now. Okay. Path. I don't know if there's 2-string directly. I don't really give a shit, to be honest. Oh my god, this code is bad. Oh my god. Oh my... What? How is it that slow? Are you kidding me right now? That is quite a surprise. That is insane. That is so bad. Okay. Wow. So we're gonna make RDTSC. This is gonna allow us to get access to the tick count, which is what we're gonna use for benchmarking. Standard ARC x86-64 RDTSC. So that's gonna let us get the tick count. And we'll do let st as oops. Yeah, IT. RDTSC. Okay, and then we'll do 10.3. We might actually need more digits here, and this might need more as well. So we'll say input ID, and the elapse is RDTSC minus IT, which I actually care about cycles per. We can do seconds per as well. I care about cycles, but chat, you probably want to see seconds, so we'll just do elapsed by 2.1E9. And then we'll do elapsed as F64 number of cycles per iteration. And then we'll do elapsed sec divided by 100. And that's going to give us kind of all of the information. So this is sec and iters per second. Yeah. Iters per second. Cycle per iter. Okay. And let's take a little look-see at how this looks. IID we can slap up here. Beautiful. And these should be sorted, and they are. Okay. So I wanted these to be sorted. That's how I put them in a B-tree map. I wanted them to be sorted so we see the same thing every time. Okay. So some of these are faster than others, which is exactly what I would expect. Obviously this is astronomically slow. And yeah, we're getting like a 1,000 a second or so. Const iters. U size is this. Iters as F64. Iters as F64. So now it is something that we can tune. So now we're getting larger data samples. And let's try and stabilize a bit. Let's just pin it to one specific core. So that will hopefully slightly reduce some of the variance of just Linux being Linux. Okay. And, wow. Huh. Okay. Okay. So then we're gonna do, let benchmark is equal to this. Move this into a closure. Time to turn off CPU freak. That also would be a good idea here. Bench. Should be able to do that, right? Benchmark, and then we'll benchmark prime and naive. Okay. Oh, that returns an option U size. Beautiful. Moves the variable inputs in. I don't know if there's a better way to do that. Oh, can I just do that? Yes, I can. Interesting. Also, black box. In this case, black box won't matter. I'd remove the type annotations. I don't think I can. Right? Can I now? Nope. Okay. All right. So Rust should correctly split this into two implementations. Black box is not needed here because it's very obvious that these are some Intel benchmarking guidance on using the CPU ID and RDTSCP instruction instead of yeah, I'm familiar with all that. Yep. Okay, we are actually getting optimized out on Prime's implementation, which makes sense. I guess nothing in here can panic, whereas mine can have allocation panic failures. So now we do have optimization issues. We can make this really easy by just doing a naive on let int is int trim as bytes to vec. Okay, and then we'll do this. We'll see if this works. It might not. Give ah. Result. And then here we'll just have input and results. Assert ns is equal to res. Obviously, that's going to pass. This may or may not prevent primes from getting optimized out. It might still get optimized out. We're going to cut down on itters. We don't need this many samples right now. And yes, that looks like it did prevent his from getting optimized, which is good. Beautiful. Okay. That's still really slow. I think. I'm not sure. Should be parametric. Yeah, that's something I could do. Let's grab Benny's implementation. This is going to be Benny. And I'm going to change this to 8. And num. Change this to a const num usize. That's just the window size, I would imagine. Num. Right? I think I ported that correctly. Benny 4 or 14. Usize. What do you do if it fails? Oh, you just panic? Okay. And you do position, so we can just do this. Uh-oh. Did I do it wrong? Did I break it? Did you add the 4? At the end? Oh, right here. Yeah. We'll just not do that. Beautiful. Okay, so let's take a look at the current winners. Iter. Numerate. Okay. All right. So these are always going to be in the same order. And so what we should be able to do is also give it like a name. I like how these are all 5 letters. Beautiful. Okay, and then we'll do this here. I'm going to get rid of these. Sorry, we're going to... we'll keep this. Let cycles per iter is equal to this. Let iters per sec is equal to iters as f64 elapsed sec. Okay, and then this is iters per cycles per iter and iters per sec. Okay, so I'll have these printing out, and then we'll have let meet results is file create use standard fs file use standard IO write. We don't need a buff writer for this. We're not pushing that much data. Log.text unwrap. And then we'll do... What is the song? That song was up before. That should have been... Eye on attraction. Probably consumer. Might have been Strangers in a Broken Land. Ion Attraction, the method. Really fun, small indie emo-ish band. Big fan. They're absolutely fantastic. Okay. Okay, so now let's do this. What are the strings that everyone pasted from? It is from this. Target CPU native? Yeah, I'll do that as well. Pop count might be always in there? I'm not sure. When was pop count added? Nehalem? I think Core 2 is what... No, Pentium... I forget what default optimizations are. It's not? Okay. Um... Right to results. ASDF. Oh, yeah. Fuck yeah, let's go. Oh, you dick. Oh, sure. Okay. So we're gonna write mute results. New line, new line. Name. Rightline. Write the benchmark name. Iterate through all inputs. Benchmark to average out performance. A bit. All right. Stop timers. This is gonna be start timers. Okay. Compute stats. And then we're gonna do write lin, and we'll do the input ID 5, and this doesn't need to be 15. Actually, just like 1 is fine for now. Let's just do 2 for that, and then we'll do a just do like a 15.5. We don't need that many sig figs. Even this many is kind of stupid. Cycles per iter and iters per cycle, or iters per second. Okay, we're not using path, but we are using it to sort it, so we'll keep it, and we actually need IID to be 2, because we're fucking idiots and don't know how to count. Beautiful. There we go. There we go. Okay, plot the plot, set term wix size 1440, 900 persist, set x label, input ID, set y label, I think I want to see cycles. I think that's mainly what I care about. Set title, this is AoC 2022 day 6 part 2. Neon silver 4310 at 2.1 gigahertz. And I think I need to escape the at. For index. God, I forget the syntax for this, dude. Plot for index in 0 to 5, log.text. I index u 1 to 2 with LP title column header 1. I have to memorize that. It's really sad that I don't have that memorized. Okay. Yep, I need to escape the at, and I forget how I do that. I think 2 slashes will do. Okay. All right. So, let's do set log scale y, set uh, grid mx ticks, my ticks, x ticks, y tick. Beautiful. Okay. So we can see that Benny's is slightly faster across the board. Let's try and get higher N. Um, let's do chunk. Let's iters is 0. Loop. While RDTSC minus IT is less than 2.1 E8. Iters plus equals chunk. So what we're doing here is basically, we are dynamically running these benchmarks for approximately, this is going to run the benchmark for approximately 100 milliseconds. And this will allow us to, basically, the fast ones will run more iterations so that we get, basically, we want to run the CPU for like a certain amount of wall clock time to get it like hot and get all of the paths hot in caches and get branch predictors up and running. RDTSC is not free. It's like 20 to 30 cycles. Actually, I think it's like 15 cycles. RDTSCP is more expensive because it does a fence. So basically what we're doing here is we are intentionally decreasing the frequency that we call RDTSC. In this case, it doesn't really matter because these are running like 15,000 cycles an iter. But if I was benchmarking something that was like a lot smaller of an operation, just like a really, if I was trying to benchmark something that took 50 to 100 cycles, I would want to amortize the cost of checking whether or not I should stop the benchmark, which is what I'm doing here. So I'm running a minimum of 100 at a time. So this can get unrolled. These can get combined together. It can kind of optimize these. And then the outside loop, is just a final time deadline on all of them. So they'll be capped at 100 milliseconds. Obviously, if it takes longer to process the chunk than 100 milliseconds, then they'll run longer than that because they don't check to exit early. So this is pretty common here. Did he enable native? I didn't yet. So we're just taking a look at this for now. 2.1 E8. Oh, yeah, let's just do... So that is pretty good. Probably need to make that mute. So we'll actually track the number of iterations it really did. And now we should get more samples, which will smooth out some of the, like, Prime's graph and Benny's graphs, right? We could even turn down... Honestly, we could turn chunking down to, like, 16. I like using powers of 2. The compiler is more prone to optimize things and unroll things to powers of 2 and register schedule and powers of 2. So it's kind of nice to just bias that in the first place. Now, all of them should run 100 milliseconds, so this will take 1.4 times 3 seconds approximately to run the whole benchmark, which is a little bit more bearable for now. Now we can see that Benny's has picked up some performance there, just because we're actually running it for a long enough time that it's slowly, building up that advantage. And let's see how reproducible this data is and how stable it is. So we'll just copy the old data and we'll just run it again. That's all we're going to do is we're just going to run it again. And we have plenty of sig figs here. We have all the information that we possibly need. Log.text. And we'll just also plot. I guess I've never done 2 for loops, but I think I can just do this. Beautiful. And yeah, it looks like, so Benny is this one. The 2 blue ones are Benny, and then the Christmas ones, oh, that's black, that's not red, are primes. So yeah, you can see there's a little bit of noise in our benchmark, which is totally fine. 100 millisecond benchmark is really short. It's not really a long time to do that benchmark. obviously we can see that there are consistent differences in some of the inputs, and that is telling us that it is important to have the ability to exit early out of the scan. But we're going to see whether or not that is the case. Are those the custom molded IEMs? Yes, they are. Will you solve day 7 as well? I've never done fucking advent of code. I had no plans on doing these. Um Didn't enable native. Yeah, no noise on naive. Yeah. Keep in mind this is a log scale y-axis. If you don't know how to read log scales, should have paid attention in high school. Did you find out what CPU cores are physically disabled from your CPU from last stream? I can't remember. I don't think so. Thank you, Moose Mounted Mage, for the 4 months. Fuck yeah. Can someone get a plushie so I can have a plushie? I'm getting cold. Okay, so let's try let's do this. Let's just without native, it does a bunch of multiplication. Yep, I totally expect that. So, here's what I'm gonna say. I'm gonna say the cost of RDTSC does not matter in this case. So we're actually gonna get rid of the chunking and averaging. That is a good concept for things that run fast, but none of these run that fast. Okay, now we can. Now we can. All right. Poyaso, you're gonna get an avocado today. Avocado. But yes, these are the custom molded IEMs. They are amazing. The cable is unreal. I don't even know that I have a cable. It's really, really, really impressive. But yeah, they're like really fun. So these are just molded to my ears, and they fit perfectly. One ear fits a slight bit better if I'm being like extremely picky, but they both fit real nice, and they just slide in there. You kind of have to rotate them in. People sometimes complain that they're like hard to get in and out. I mean, they're hard to get out, but honestly, I've had no issues getting them in. Maybe I'm just used to putting things in my ears. How's Avocado doing? Avocado's been complete for a couple months now. And it's fucking fantastic. I've been thinking about dropping some money on some. Yeah, I think I got the UE lives, which is completely unnecessary. I think the UE there's like a UE there's like a $600 or $800 model. Reference? Reference remastered or something like that. I think it's reference something. I think that is the best bang for your buck that you can get. I think you can go a little bit cheaper than that, but you lose, I think, like all but a couple drivers. So, what brand? Ultimate Ears. They're kind of like the biggest one. They got me mine in like a week or two after I got them my molds, which is wild, but okay. I really do need to pump my voice back to myself though. I don't have a way I can really do that through my setup, unfortunately. Actually, now that I have my mixer again, I can do that. I don't know where my fucking output is, but I actually could set that up. I wonder what ports I have available hard now. So Logitech, is that what they are? I might have outputs. Might have outputs I can. You keep moving your outside mic's pickup range? Hello? 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 Yeah, I know. I'm thinking about getting a shotgun microphone. I think it would be better. I mean, my head moves a little bit, but I would mount it up on my camera. It would get this shit out of my face, and I think it would be a little bit more consistent for my head movements. All right. All right. So, what we're gonna do? Probably mainly when I look up at my other monitor. So, what we want to do is we were just changing this benchmark to what we're going to do is we're going to pick the fastest iteration in this window. Okay. So, this is a slightly different way of doing things, but this is actually what I prefer if I can afford to do it for a benchmark. So, what we're going to do is we're going to assert that it matched, and then we're going to do let mute min is standard U64 max, and then we'll do min is min.min rdtsc minus it. Okay, and then this is track minimum time. Then I don't even care about the number of iterations. So what we're going to do is we're just going to run for approximately 100 milliseconds, and we're going to record the fastest one. Okay, and then elapsed. In this case, elapsed is just going to be min. And iters. Let iters is 1. Let's just say iters is 1. Here we go. So now, oh. So this allows us to basically get rid of all like scheduler and weird noise on the system because we're taking the minimum time, which is basically the best case scenario. So these numbers are likely going to be much more consistent. So let's remove the old and new data. Let's run this. Let's copy that, and then we'll run this. So now we're basically comparing these two different runs, and we're going to see how much variance there is. And whoops, didn't mean to do that. Doesn't really matter. Just let it finish. There we go. Interesting. Interesting. Wow, so Primes is really consistent. Look at that. Those lines are basically on top of each other. And then Benny's is let's go absolute scale. So let's switch out of log scale, and then to do that, we're going to disable the naive benchmark. Okay. Keep in mind we're very zoomed in on the data now. Wow, not as stable as I was hoping for. Obviously, we can see the pattern. So that pattern is clearly inherent in the data. We'll probably see that Benny's probably has similar shapes. Yep. Similar shape there. And similar shape there. Benny's is way less stable, which I don't really understand why. That's not like a criticism or throwing shade. It's just like I actually don't know. We're also not running it in its correct operation mode. I'm surprised how much variance there is here. 18,000 to 23,000. That doesn't seem right. So let's try and pin to a Numa node, I guess. I think I can do both. I always forget the syntax for this. Preferred node. CPU 1. Does that also do affinity? I think that's also doing affinity. Let's try and move it to 3 and see if 3 spikes. Yes. Okay, that's also moving the affinity. Is that only core though? Only execute process on CPUs. Blah blah blah. Relative CPUs. Okay. Try to allocate on the current node of the process, but if memory can't be allocated, fall back. Preferably allocate memory on node, but if it can't be allocated, fall back to other node. I want like force. Only allocate memory from nodes. Allocation will fail when there's not enough memory free on those nodes. That's -M. So if I do M2, this should fail because I don't think I have a 2, but I should have a 1. This should be the wrong one. And this should be the right one for that core. So first we're going to get the benchmark. Oh! Okay, surprisingly not really a difference there, but it did seem like NUMA control really helped us, and I closed that terminal like a chungoid. So we're just going to use this. I think. Let's try it again. Yeah, I mean, those are now way more consistent. Way more consistent. Beautiful. So let's look at the 2 primes. Yep, those look great. That is way better than I thing though. It's weird that we're testing your OS. Oh, thanks, Thon. Someone sent me their thing from this Discord. Temp. Got another input. Okay, let's do this. We could do this in my OS. I don't understand how this is more stable now. Doesn't really make sense. Okay, that wasn't stable. Oh, I must have gotten fucked on scheduling there. Okay, this system might just be too noisy. You're streaming on this shit too? Yeah. Benchmarks on Linux? Yeah. Okay, we'll do it in my OS. Fuck. What do I have? Polar Sol, that is good. Let's see. Let's see. Is Polar up right now? Okay, it's not plugged in. Be right back. All right. Okay. Let's see. Let's see if I can get this to work. Okay. So, okay, let's restart the server. Actually, um, do I have let's see if I have Pixie enabled here. Flags lack? What? List. Flags lack. Let's see. Is that the right? Yeah. Um, do I not have a connection there? That overpainting without spaces is so fun. Yeah, right? Isn't that fun? Is there a way to like forcibly set the size? Um, policy static. Let's go into the BIOS quick and let's see if we oh, I think I could go directly into the BIOS from EFI. Didn't have to reboot. Oh well. You bitch. All right. Let's see. Let's see how this computer boots up. But it found my nick, which I think means I'm curious if I need to configure that nick. I really hope I don't have to configure. Oh, that's doing Pixie. Oh, that looked like Pixie. Um, media presence. Okay. Oh, did it just drop the address? Is there like DHCP? Can I DHCP? Like clearly it has the thing. How do I? Sets the IP address. A renew configuration. Oh! We got an address. Oh my god, I can't believe that's actually set up correctly. Oh, thank you, Jesus. Oh my god, I didn't want to configure that fucking switch. Oh my god, I would have had to get up my serial port. Oh my god. Okay. Oh my god. Oh. Oh. Oh, it just means I don't have TFTP running. I think I can exit and it will. How do I boot? Is it just boot or some shit? God, I suck at this. Uh how can I just have it like redo the boot? Can I do that? I mean, obviously I can manually boot from TFTP here, but that's not necessarily what I want to do. Let's also update Rust while we're at it. Um load mmap. Uh Is there no way of doing this shit? Let's just see what happens. Let's go into Sushi Roll and see if Sushi Roll still builds. Make run, I think, will build it. Oh, Target run. Fuck me. Oh god. Oh god. That's fine. Unstable. That's interesting. This actually used to be stable and used to work, but now it's not apparently. Split debug info. Where am I even setting that? How do I say it's okay? Is this bad baby? Yeah, this is. Oh. I don't know if this will boot right now. I might not have BIOS mode enabled. Yeah, so I'll have to go into. Can I do setup or something? Uh, Exit sometimes will get me into the setup. Really? Not on this server? Oh, there we go. Exiting twice. Nice. Okay, let's see what kind of configuration we have. Let's see if we have everything reasonable. CPU configuration, everything looks good. We have hyperthreading disabled. That's fine. We're gonna go for maximum reliability. Hardware prefetcher, all these things are good. ASNI, extended APIC is not needed for this setup. Max performance, super power mode, BIOS controls EPB. So all these should be totally fine settings there. Okay. Chipset configuration. None of these should really matter. UPI. Oh, actually, we have SNC subNUMA clustering, which is good because we'll actually use that. And that looks good as well. Okay, so next we need to go into boot and let's give dual support. Oh, you know what? This NIC probably doesn't have non-UFI boot. Unless Let's go into probably PCIe configuration. And oh god. Oh god. Oh god. I have no idea which one it is. Oh god. Oh god. Oh god. Oh. Well, it will be on a times 16. Can't be on a times 8 because it needs a times 16. Let's just put them all to legacy. There you go. And we don't have any PCIe cards in there, I don't think. I think only the NICs. So, like, who fucking cares, right? I ain't a bitch. I ain't scared. All right. Yeah, now it's gonna work fucking great. We gotta fix this dumbass shit too. How do I allow this? How do I allow debug info packed? That's another thing I'm gonna have to solve here. Stop watching for 30 minutes. I have no idea what's going on now. Nor do I. We're getting it up and running on one of our servers in our OS so we can actually benchmark it because Linux is proving to be a little too noisy for this benchmark. So we're spinning up this server quick. Do you even need debug info? No, I could just turn it off. Split dwarf? Only if that is set? Can I just turn that off? Can I do that? Does it just default to split debug now or some shit? Oh, come on. Don't be a bitch. We'll just turn off debug on release. Fuck it. Don't give a sh. Oh my god. Really? Alright, hopefully we're in. It's weird. That flag was in there this whole time. Okay, beautiful. Oh, yeah. Let's go. Let's go. We are in. We are ready to hack. I don't remember whatever the fuck we were doing before, so let's just do this. Git status, git commit am, IDK did something on stream about identifying cores. Okay, great. Sweet. Are gonna run the build. All right, so now let's just now we can just turn everything off. Woo! And let's assert we have AVX-512 as well. All right. Okay. Everything's working. Woo! Woo! Nice. Nice. Let's fucking go. EZ clap. Let's get some easy claps in here. Okay, and let's actually use a fucking file now. What is this called? Advent of Code Day 6 Part 2? Let's call it main in there. I'm such a fucking good programmer. Mod. Beep 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 bop beep 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 boop bop boop beep boop bop boop beep bop boop beep boop beep boop bop boop beep boop bop boop beep bop boop beep boop beep boop bop boop 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 beep boop bop boop beep boop bop bop boop 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 beep boop bop. All right. Do I have node ID by any chance? Come on. Oh, it's a function. Little Stromboli function. Stand-up Leo, no, thank you so much for the 17 months. Hell yeah. I like the easy class. Fuck yeah. All right, let's see what we got for nodes. Beautiful. 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 Kernel source thread local. Why is the display scuffed? Because it's just running threads. If is BSP. What do I want? Node ID, core ID, APIC ID? I think core ID. Looks good to me. Do I have sleep? What is sleep take for args? I have no fucking idea what it takes. Probably microseconds. Microseconds. Let's do a millisecond. 10 millis per core. Here we go. This will space out their prints. That'll do it. that looks fantastic. And that's all the cores. So 1 through 95, core 0. In this OS, core 0 never participate. You can never compute on core 0. Core 0 is designated for device accesses and other IPC sort of stuff and allocations. Okay. Beautiful. Beautiful. Let's just run that again just so we can feel good. Oh, yeah. Oh, yeah. Let's check out the ACPI. Let's turn on verbose mode. Let's just see what our memory mappings look like. Beautiful. So we have... Yep, that makes sense. Node 0 has some of its stuff stolen, and then we have 7 nodes. We technically have 4 processors. Each one has 2 nodes because we have sub-NUMA clustering enabled. Fantastic. Fantastic. Let's add like a total mem count too. Let's do that as well. Node free sum. Total free memory. Perfect. I don't know why I'm recomputing it here, but I am. Whatever. Not gonna touch it. Reserved cores, what is it? A gaming console. There we go. Is that the correct amount of RAM? Divided by 1024, divided by 1024, divided by 1024. 766.31. That sounds good. Sounds like everything is active and ready to party. Whoop, woo! Chat, raise your poggers if you're ready for perf. God, I love this OS. God, this OS is so fucking good. So fucking good. Let's see if calibration succeeded as well. Oh, I don't have poggers enabled? I guess I want this in thread local. Relax, chat. I haven't worked in this OS for a while. I forgot how it works, okay? Relax. Relax. You're stressing me out, chat. CPU frequency? This should be 2300, I think. Let's go! Let's go! Clean fucking code. Perfect code. No flaws. Everything works. Out of the box. No problem. No issues. Perfect. Let's, what core? Chat, pick a core number. Pick a core number. What core do we want to run on? Pick a core number. What are we going to run on? 69? 69? 69? 42? Yeah, it's clearly going to be 69. Yeah, all right. Disable all cores other than 69. Now we don't need the sleep. All right, we're on node 5. Node 5. So we're on a completely different physical core from the BSP, which is good to reduce the noise. Time to program bugs now? Yeah, now we get to see how shit this code is. Give me love. Give me love, give me love, give me love, give me love. Is this gonna build? Oh, fuck yeah. Is this just gonna port right into my OS? Where's beach reset? Let's go! Let's fucking go! Let's go! Easiest shit I've seen in my life. That's what I like to see! Mama say, mama sa, mamaku sa. Let's go! God, I write such fucking good code. Okay, we gotta get the impies. How do we want to get the impies? And I know how I want to get the impies. Include bytes? That's the type beat that I'm thinking. AoC Extreme Edition! Extreme! We got perf! Pixie download file? We're not doing that shit. I don't have Pixie support in my OS. I don't think. Only in my bootloader. We're including these bytes. A 4 hundo, sure. I don't have a network driver on this OS. Well, I don't know how hard it would be. This system has 100 gigabit NIC that I've never had a driver for. And I think it would take more than like 30 minutes. Probably like an hour to get my driver working on this NIC, I would imagine. Probably in that ballpark. Once I do that, then I would have full like TCP stack and everything. But I just don't have a driver right now. We're just gonna cope right now, okay, chat? Chat, it's a hard-coded path. Fuck off. It's okay. Chat, can you relax for 1 fucking second? It's an absolute path in a fucking kernel. It's fine. It's fine. It's fine. It's fine! I'm a fucking idiot. I chunged it. I totally bennied that up. God damn it. Zero us not support file systems? Fuck no. No, I hate file systems. I am not a fan of file systems. Let's go. Fuck. Let's go. Let's go. Build. Build. Let's go. Cleanest shit I've ever written in my life. Yeah, I never do file systems or disk drivers. I want to write an OS for my new storage server because Linux is really fucking it up. But I really just don't I don't do compute on servers with disk. Like, ever since I've had 10 gigabit NICs, I've just had no reason for local storage. It's just extra fucking maintenance you have to do, more distribution of your drives, more distribution of where you have to check for logs and errors. I centralize all my storage on one server. So, all right. Boy problems. Boy problems. I'll have to get rid of the right line temporarily. I think everything else will actually port. RDTSC, I think that's just going to be CPU RDTSC now. Boy problems. Who's got them? I've got you. Na, 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 na. Don't know what to do. I think I broke up with my boyfriend. Didn't really care. Let's fucking go! Okay, Benny's got optimized out. Benny, don't get excited. Yours got optimized out. Relax. Relax, Benny. It's not that fast. Benny is cheating. 22 cycles is the cost of RDTSC. Yeah, if I just got rid of this, if I just comment out the entire thing, here's what happens. Ready? 22s. Got double. Don't know what to do. I think I broke up with my boyfriend. Really care. I got worse problems. Broke up with my boyfriend. God, this song's so fucking good. It slaps so hard. Worst problem. I mistyped Max for axe like I'm gonna do to Benny's code. Axe it. Ayo. Ayo. I got na, 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 don't know what to do. Think I broke up with my boyfriend. Really care. I got worse problems. Broke up with my friend. God, that song's so fucking good. Yeah. So that's why we run in my OS. Let's fucking go! Let's go! Mamma mia, cacio e pepe! Parlez-vous français? All right, let's run this benchmark on Linux. What do you think this benchmark is going to look like on Linux? All right? Fuck. Let's just put this in mod. Hogged. Hogged the fuck out. To get you out. Know you had a rough time. Yeah. Yeah, this is what it looks like on Linux. Let's try it on my OS again. Here's my OS. And let's see, let's try it again on Linux. Here's what it looks like on Linux. What a heap of shit. Yeah, but Linux has a working NIC. How much you want to bet I could get this NIC working in like under 30 minutes? We could look at the average too. Here you go. Here's an average. That's not bad. That's not bad. I don't know what the fuck happened here. Guess I got scheduled out for a bit. Then these got fast again. These are averages. Averages over the course of 100 milliseconds. How is it off by that much? Fuck! How? How? What? How? That makes no sense. What the fuck? God, this OS sucks. Fuck Linux. Oh, mine's all over the place too. That's really interesting. Oh my god. That's one more cycle. Sus numbers? These aren't sus numbers. These aren't sus numbers at all. These are not sus numbers. I can tell you that right now. Oh my god, my OS is so fucking good. Oh my god, my OS is so good. I don't trust that many OSs, that many numbers with threes. Okay, I'm not gonna rebuild it. Why can't I establish the connection? Why can't I establish the IPMI connection? Is it power? Yeah. All right, I'll show you why these numbers aren't sus. Does my OS support popgun? Yeah, of course. It's just a flag. If I don't have it enabled, I can enable it. These numbers aren't sus. I can tell you that right now. You're about to see why this OS is so fucking great. The fact that these numbers are this is why this OS is so fucking amazing. It's insane. It's insane. It's just fucking wild. We got to go into the BIOS though. And I forgot how to go in the BIOS. It's like Control 12 or Delete or 12, F12 or... Oh, Jesus. Oh, let me in! I canceled it. I canceled it. I canceled it. I canceled it. Oh, God. Cancel. Don't boot! Fuck! How do you do this? Like set chassis boot dev BIOS. And then I reset. Server boot times, yeah, server boot times. Server boot times do be like that, though. But yeah, there's a chance I don't have all the flags enabled. I think I will. I think pop count is not flag based. I enable OSX save, AVX, SSE, and yeah, and I think if I just set that to an F, I think I get AVX-512 as well. Okay, let's go and here's what we're gonna do. Because chat was all pissed off, said that my OS sucked ass. Fire technology, disable. There you go. Now we'll run the same test. And you're about to see why this OS is so fucking great. Are we going on a little bit of a tangent right now? A long way home. Hey, Big Rick, how's it going? Dropsalt, what OS are you in? This is my own OS. This is called Sushi Roll. That's the code name of the OS. What are you doing? We're optimizing an advent of code problem, but we had too much noise on Linux that was preventing us from optimizing efficiently. Let's go. Here we go. Fuck! We got this. We got this. We got this. Maybe it is something else, but I don't think it is something else. I mean, it could be. It could be something else, but it might not be something else. Let's see. This wouldn't happen with a working Nick. Bunkas. Hyperthreading off. Oh, I had speed step off. Okay, so it is something else. Dicks. I'm just gonna turn off power technology though. I like that. Let's go. Okay, then it is something else. My OS is just ass then. Son of a bitch. Son of a bitch. My OS sucks. All right, it'll be sufficient for what we're doing. Oh, this song slaps too. Carly Rae just fucking slaps, dude. Bum, 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 bum. What was your hypothesis? I thought it was turbo. I thought it was turbo giving me like a 30% boost exactly. So, how are these looking from the min? These look pretty stable. Yeah. Um, I don't know why I love stats so much, chat, but I do this shit to all my programs. This is like a 10.6 type beat. Eight. 1, 2, 8. Fuck. This is going to show me the multiplier from the mean, which basically tells me my stability. Yeah, so the naive one's really stable. That makes sense because it's slow as balls. Um, but yeah, the mean. I mean, this last one doesn't really matter. So let's disable optimizations of this. Um, I don't want to unwrap it. Um, I mean, you can just do unwrap or not 0. I think the unwrap probably means this ASM is probably not needed. So I think the ASM, I think the unwrapping will actually cause Benny's to stop being optimized out. So let's see what happens here. No. Okay, cool. All right. So basically what we're doing here is we're just throwing it into assembly to make sure that the compiler is not able to reason about where that value is used. So it just has to assume that that value can get used, at least in this context. And it's not used later, so it's just inside of here. It basically makes sure that it actually computes that value, and it basically makes that function volatile and actually run. So that actually helped our stability a lot, which is great. So, um, let's do stability, and we're gonna do this in parts per million. And if we're doing this in parts per million, we probably want like a 10.3. I like ppm here. Gotta confuse the compiler, keep it on its toes. What's interesting is that this is actually cross architecture. Nope, I don't want to do that. -1. I guess mean minus min. Is that how you do error? Is that the correct way to compute error? I always forget error. Like, do you which way you subtract and which way you divide? Pretty sure this is the way you do error. I mean, this makes sense. Okay, beautiful. So I would say these are pretty stable right now. Not insane. All the benchmarking should happen inside of here. I don't think a fence is necessary in this case. It's kind of stupid. We could try it and see if it helps. Let's just M fence, full M fence. We'll M fence and we'll jail everything. Let's just go for the double decker M fence. My favorite. That hurt stability, except for on Benny's. Okay. Makes sense. Stat tracking should be pretty cheap. That shouldn't really be affecting much here. It has a non-zero cost, but it shouldn't be too bad. Okay. Oh, maybe it did stabilize things more. Wait, really? Still no pop count? Yeah. These are like 10s? We have one that's really low, but, okay. Huh. Now we're not getting thousands on Benny's? There's still some noise there. What the fuck happened there? Huh. I think it's pretty stable. Okay, let's target against this. See what happens. Can I do that at a function level? Um, Target feature enable. Do you know what the feature is, Benny? Technically, do I just need to set that on this? Can an FN coerce into an unsafe FN? Yes. So we're at like 25, 24. Let's see if we notice the speed up. Yes, that clearly took effect. Do you disagree that that didn't take effect or did take effect? That definitely took effect. There's no way the numbers halved. So there we go. So that worked. All right. So let's turn everything off but min. We'll cut down on some of our costs. I know we spent some beautiful time on that. We're just going to print the minimums. My OS is stable enough that minimum is totally fine here. Oops. And here I'm going to do a loopage. Okay. Okay, and then we're going to say if and minus IT is greater than 210. Beautiful. I bricked it. What? Am I dumb? Do I not know how computers work? Oh, yep, you're right. Here we go. Raise your poggers. Beep. Nice. Nice. And let's see how stable the minimums are. Let's just whack these in here. Run it again. So full reboot. Let's see what we get now. Yeah, these are close. We're off by 20 cycles. 20. Exact. Yeah, I think it's pretty stable. All right. Good. Good. Beautiful. Beautiful. Seems pretty good. Yeah. 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 I mean, we could run the same benchmark on Linux, right? We should be able to just pasta this code in, right? To Linux. Let's see what Linux does. Let's do the same thing. All right. Here's Benny's on Linux. Let's try it again. Okay, I'm impressed. Okay, there's no reason to go to my OS. It works the exact same on Linux. Yep. Oh, well, this one's way off. And 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 this one's way off. Okay, you can't use Linux. Linux doesn't work. JK lol. JK lol. These ones are all good, right? Yeah, these are all fucking good across the board. Yeah, because my OS is fucking perfect. Of course. All right. Let's just close the Linux stuff because it's trash. Beautiful. All right. Taking the minimum seems to negate the OS noise. Yes, that is the intent of minimizing it. Okay, we got Prime and Benny here. And good night, Linux. Yeah, get out of here. Can we format this better? Can we do a better job than what we're doing now? Fit them all in one line. All right, whatever. We'll just start working on optimizing it. Because we can beat Benny's shit numbers. Easy, no problem. Just, we're going to condense this a bit. Nah, we're just going to do this. Just a dance. Oh, I can't break from in there. How do I want to structure this? It, technically 230 for this system. Not that it matters. Let's go. Let's go. Here we go. Amaranth Waiting Room, thank you so much for getting gifted a sub. I appreciate it. Oh, I never tweeted that I was streaming. Let's do, oh, I gotta clickbait my stream title. I gotta be Advent of Code, in my own OS with AVX-512. There we go. That's some clickbait right there. That's the shit that you want to see. You'll love to see it. Okay, and then we'll do this. All right, here we go. Bam. All right, there we go. Completely fucking fake title. All right. Funk. Unsafe FN. Slice of booties. Beautiful. Prime Min and Benny Min. Isn't that Benny? That's Benny Hill, right? No, that's clown music. We're almost there. Yep. Yep. Hey! We did it! We did it! We compiled code. There we go. There we go. Now it's fair. Now it's real fair. Okay. Why is line 93 unsafe? Because Benny's implementation uses a CPU feature, and so we compile this code so this function can use that CPU feature, and in doing so, that means it's unsafe because it is up to us as a caller to ensure that that CPU feature exists before we call that function. Otherwise, it will crash. Naive prime Benny, naive prime Benny. And yeah, so now we see all of the stats for all of them. And these should be stable. These should be pretty fucking stable. Yeah, so for reference, here's the old data, here's the new data. And it looks... That's not identical for everything, is it? That's not literally identical for everything, is it? Yeah, it's literally identical. Oh, did I not scroll up for the old data? Am I dumb? I'm dumb. Yeah, it's different. It's so different. Yeah, okay, we got scammed. Fuck me. Damn it, our code sucks. It looks pretty stable. I'm not losing sleep over it. Not much more I can do at this point if I don't want to go absolutely mental here. I mean, the first one, the naive one, I don't expect to be stable because it does allocations. This is a good moment to mention, no, I deduped all the inputs. Really, the only ones that I care about is actually the second and third column. The first one does allocation, so that's going to be really unstable. So now we just have to beat the performance of these. So now we actually get to do the actual advent of code problem. How does that sound? That sound fun? Raise your hands if you think it's fun. All right. I'm gonna switch out of my headphones so I can make some food. Be right back. Gonna, I don't know, make a pizza. All right. All right. We're gonna hack. Can we download this OS? No, it's not. It's not public. God damn it, dude. I'm just gonna unplug that fucking UPS. So fucking annoying, dude. Okay. So, everything's stable. We just need to solve this problem. So, what are creative ways that we could implement this? First of all, let's see if we have AVX-512 support. And I don't think we do right now. Let's just try it. Let's just do it up here. Yep. That's me unplugging it. All right. There we go. Okay. Now we won't get those prints anymore. Problem solved. Unsafe. We'll do like a VP turn log D ZMM0 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 0. Hopefully that is the right syntax. Okay, nice. So, that is not a problem. We just have to enable it. I think it's just one more bit, isn't it? No, it's like 4 bits or some shit. Looks like 5, 6, and 7. And then this is AVX-512. Op masks. AVX-512 enable and Xsave feature set can be used for K-mask regs. AVX-512 upper 512 bits. And AVX-512 upper ZMM regs. Those are the 3 enablements. 5, 6, and 7. Let's go! Let's go! EZ. EZ clap. EZ clap. Yeah, sea cereal's not public. Chocolate milk is, and it's similar. Now we basically every fucking... We have basically every feature enabled now. There isn't much more that we cannot enable. All right, so we have to do 14 at a time, which is fine, and a fixed size. So let's improve these. First of all, let's just take Benny's and make it faster by making the input size constant. Denny. Those are gonna be Denny. 4,095 bytes, right? Can I even do this? I don't think so. Oh! I can. Fuck yeah. Ah, the triple amp. The triple amp. Actually need to deref that once, don't I? I could also just add slice. I think. That'll coerce it. They are 4,096 with the LF. Array windows better? Yeah, array windows will probably be better as well. What? Who sent me this? Is this a scam file? Did I get scammed? I probably didn't copy someone's correctly. Just remove it. Okay, 4,096 all the way through. Yep. So these are inputs with the character set this. And then the last byte is a OXOA. You beat me at AoC. You crushed me, dude. I got absolutely stomped. Look like a fucking clown now. Suspended in this disaster. Okay, let's do Windows, array windows. To be honest, when using an iterator, it's gonna be hard to get it much faster. Iterators just kind of suck donkey dicks. LVM just really doesn't like the code gen. Didn't I build that? No. Okay, I just didn't build it. I just missed the arrow key apparently. Stuff in this disaster. Magnetic. But I think we're gonna take a completely different approach from these. Okay. Okay, let's just FN once these. No, you're still there. I know you're not empty. Impulse FN one. You can't do impl on that? Ah, son of a bitch. Really? Really? Can I just do this? Just fuck it? How the fuck would I do this? How do you do a generic unclosures? Can you? Can you not pull the closure out into a function? Yeah. Yep. Yep. Ah, dicks. Oh, it's okay. It's okay. It's okay. It's okay. It's okay. Relax. Relax, everyone. Everyone relax. I know you're not empty. Like a this type beat? I never wanted to be treated like a psycho. Benny's one's always got to be unsafe. Classic fucking Benny. Always unsafe. Always danger code. Okay, we're like we're in the right territory of getting this to compile, I think. Oh, Jesus. Where is it? Where's the missing curly bopper? Is it the semi? No. Son of a bitch! I was looking at the first error. Yeah, but I'm lazy. I think you can use unsafe as the opening scope of a closure, right? Yes. Yeah, that wasn't it. Okay. Let's say. Is that... Wait. Oh. EZ. Don't get all sentimental about... this is going to be really slow because I think it's literally going to copy it every time. For that array. Yeah, I'm pretty sure it's copying that array every time. Honestly, pretty impressive perf for copying that array every time. It's not fair. Things can't compile simple code. Wow, perf loss? Really? That because it's... Really? Why is it slower, though? Array windows? Really? Is it array windows that's wrong? No. Oh, fuck me. No. Relax. Relax, Benny. Relax. I forgot how hypersensitive your code is. Okay. It looks like it's able to optimize the windows. It doesn't look like we've made any change. And I don't think directly giving an array will help. I think this will hurt it. Yeah, I think that's making a copy of the array. Okay. So all we have to do is beat this shit perf. That's not really that hard. But yeah, this is Benny type code. Yeah. Oh! 2 cycles faster. 10 cycles faster. That's nice. It's below noise floor. All right. So, here's the thing. If you've missed the prompt, basically we have an input of characters, and what we need to do is we need to find the index where the characters... We have to find the index where the characters do not have a repetition in a 14-byte window. So we have to get a 14-byte window and check if there's any repeat characters in that 14-byte window. And Benny, I don't know if you're aware of a faster solution, but I think yours is the fastest I've heard of. So, the question is, what can we really do to improve it here? So, interesting. So Benny went to basically he makes a bit mask here and take num -1. For each, we generate a filtering mechanism. Or no. Filter. So we take the first 13 bytes of the input, and we then use that mod 32 to set a bit in the filter. It's not really a filter. Oh, okay. So that's interesting. On the first 13 characters, I XOR one incoming symbol and one outgoing. I see. Oh, so you're pre setting up the filter. So you have two sliding windows, two sliding bit masks. And you're using XORs to rotate them in. Looks pretty clean. I like that implementation. I like that. That's really cool. I like using the XOR to basically shift things off. Did you try using a rotate or like a shift where you just shift them off into oblivion? Or I guess you can't in this case. Yeah, in this case you can't. Correct. Yeah. Yeah, you're using the number of the you're using the character ID, the U8. You're modding it against 32. And mod 32 is good. Your state, so really the only issues I can really see here, obviously pop count, but I think pop count's pretty cheap, actually. And you do 2 fetches of the input, but w.len, the last thing in the window. So the biggest things that I could see being issues here is A, just using iterators. Obviously, logically, there's no issues with using iterators. Like, the logic makes sense. But Rust and LLVM just often don't do good iterator output. Kind of like the range syntax sort of stuff. But I don't think position or array windows, really any of these, have those traditional issues, especially since the iterator is not escaping this function, which means the compiler can kind of know that the entire like iterator can just be discarded when it returns, rather than like thinking it might need to flush out some internal state to memory. That's one issue you mainly see with iterators, is like iterators internally have a structure, like a state of like where they are iterating or other things. And ultimately, sometimes the compiler struggles to prove that it doesn't have to flush out that state, especially if there's like panics or things. So I doubt there would be bounds checks on this W index. That would be fucking wild if there were. I think that would just be really, really, really really unlikely here. Like, that just shouldn't matter. If the compiler can't prove that fucking array index, that's fucking wild. And yeah, same code, so obviously it was able to prove that, especially with array windows. That's like the biggest reason why I like using arrays over slices is that arrays make it a little bit easier for the compiler to like know what the length of an array is, which makes it a little bit easier for the compiler to have const prop stuff more local to where you use it, rather than like if you have a slice that's always the same size, yes, the compiler could potentially const prop that size through, but the further you get away, the further, like, in the program, the further you get away from where things are used, the more, like, distance, the larger thresholds have to be in optimizers and compilers to, like, bridge that gap and connect the two. So, like, you can have a known slice length where the compiler knows the length of a slice, but it knew that so far away, and that information is lost by the time you need the length again. Or, you know, the like medium IR or MIR or MIR or whatever it is in Rust, like, it could produce really verbose code that kind of explodes when you're doing iterators and doing slices, because I would imagine that Rust is not, it's probably doing some length optimizations, but a lot of these optimizations are handed off to LLVM. And one of the big issues you see with, like, heavily templated languages like Rust is they will traditionally produce extremely bloated, expanded out code to LLVM and rely on LLVM to do DCE, dead code elimination, as well as constant propagation and, like, deduplication of code to reduce it down. So it's basically like, it's what, like, most people would program. Like, if you were to just naively program something, it'd be like, oh, I'll just expand out all the templates and expand out all these fields and expand out all the length checks and all the trait calls and all of those things, and then just let the optimizer collapse that all down. And in theory, that makes sense. But in reality, optimizers have thresholds. They have to. They have to have thresholds of, like, how much time are we willing to spend unrolling a loop? How big of a loop are we willing to unroll? How, like, all of these different things, which makes the order of operations matter. If you expand a bunch of templates and the compiler determines unrolling before it, like, deduplicates or, like, packs those in or puts them in a function call or something, you might end in a situation where the compiler's like, nope, not gonna unroll it. I've decided unrollable, too much shit. And then in a later phase, it deletes all the fucking code and it ends up being like a basic index. And then now you have this basic index that didn't get unrolled. And there's thresholds for so many things. Time, like actual time spent optimizing, function depth, function size, bytes generated, like iteration count of iterations, nesting of variables, register scheduling pressures, memory access frequency, like all of those things. And ultimately, the more you expand your code out, and the compiler does, which is what happens in like templated languages, the harder you make it for the optimizer to ever get it back to the state that like you kind of knew. Like when you template something, the act of templating a function is already like a pretty strong hint that this is likely going to end up either inlined or in a function, like in its own function. And those lines can get a little bit muddied when you go into optimize, mainly traits. Traits are like a bigger example of that, where things just expand out. If you've ever looked at like Mir, I forget the tool. There's like a crate you can cargo install to like look at the Mir output. Obviously, you can do it through Rust directly, but there's some things that make it nice and pretty printed. It's really verbose, and I could not imagine ingesting that as an optimizer, to be honest. So that's why I avoid iterators in a lot of situations. Is iterators are a great example of that. Like, oh, well, the compiler can just prove and remove these things. It can know that the iterator is a temporary thing that's only used inside the function, and thus it can turn it into a for loop. And then for some fucking reason, something gets so far away or hard enough for the optimizer to compute that it decides like, oh, I guess the iterator is actually not a for loop. I have to assume that this iterator is just a normal structure like anything else. And thus, when I do function calls, I have to like flush all of the state to the memory of that structure. I can't like keep things around in registers. Things are now getting flushed to RAM. Things are getting fetched back from RAM because it starts turning into like a memory-based object at that point. So I say use iterators and check the code gen. I agree. Like, that's what I do as well. Like, personally, that is what I do. I'm going to throw my pizza and be right back. All right. See other fast implementation that I saw on a Discord? Find disjoint windows, mask, last known position. That's a dynamic memory access, which is gonna kind of suck, but let's grab it. W's the width in this case. Ass. Looks worse across the board. Well, some things are better. Most are worse. So I think what we're going to do is we're going to use... for the one that we're testing, which is the last one, which is Denny, we're going to give the scale... So there we can see how much slower it is. The factor, we're using Benny as kind of the baseline, which I think is totally fair. But yeah, I mean, this has a dynamic array index, and that's just going to kill you pretty much immediately. Like, this is not free. This is very expensive. This operation is like... This is the most expensive operation in the whole thing. There's also an if statement with early termination. So is this. There's also early termination here with position. My theory is, since these are 4K inputs, obviously this is not the case if the inputs are larger than 4K or dynamically sized. But we're hyper optimizing to this problem. And let's see, what are we gonna call this? Zenny? We're just gonna assume a Zennial made this. We'll call this Zenny. And then Denny. Denny is gonna be the one that we're working on. And I'm gonna switch Benny and Zenny. So they're gonna be like roughly in order of shitness. We need another, a Kenny. Well, yeah. Here's my solution. This is my Denny. There we go. Okay. So we can see that pretty much across the board, there are some situations. Actually, there were input 2 and input 10. It performed better, but everything else it performed, I would say, significantly worse, to be honest. That's a pretty big factor of shit worse. So what we're going to do is I'm going to implement my own implementation now. 4096, we're going to call this bytes. Actually, I'll call it input. And then I'm probably going to assume 14-byte windows for most of this work, but let's see. Obviously, we're going to have a different feature set, but so there are a couple different ways that we could implement this, and I want to see what happens. I'm going to take Benny's as a baseline, and we're going to see if we can zoom it up a bit. So this first filter needs to run, which makes sense. And then 4 windows in this. I don't know how fast Windows is, to be honest. Benny, is this correct for the first thing? Should you skip one since you pre-compute this filter? Because you take 0 through 12? Oh, you do this prior to getting rid of the first. Okay. Yep. Okay. Okay, what I want to do is I want to figure out how long does it take to just read all bytes. One by one. One by one. So this is very inefficient. So this is byte at a time reads. But what I'm trying to do is I'm trying to establish baseline costs, right? So what I'm trying to determine, this isn't the floor because we can read it in larger chunks than this, but this is the floor if we do byte operations. This is literally the fastest we could possibly make it with no logic, just reading them byte by byte. So let's see where we're at there. So it looks like there is room, assuming that you could make the logic have 0 cost, there's maybe room for like a 5x. Right. Right. So that's like, this is like a really good thing to do when you're doing benchmarking, is like, okay, what is the cheapest possible thing that you could do? I would say in this case, this, right? Assuming that I'm not reading it in chunks. Yeah, if I can read them as words or quad words. So this immediately gets me to thinking, okay, we could find the fastest we could speed up Benny's is a 5x. And let's actually sum everything and let's have a total. I kind of don't like this, but we're just gonna do it. Just gonna do it. Okay. Heroes. It's just gonna make it easier to like add things if we want to add extra ones. 0, 1, 2, 3, 4, 5. 4. 4 over... Oh, I just changed the way I printed them. Okay, here we go. Min. Replace that with mins. I'm being very careful to not use, like, loops here for the different algos to help inlining. That's the only reason I'm doing this weird patterns. We'll use a tuple here. Zero zero one one two two three three four four. Your path. It's like real world. Mins. I could probably get away with arrays here. Like, these benchmarks aren't that fast. So we're not like, I'm really used to doing like really tight benchmarks where the cost of the operation is expensive itself. These need to be not zeros. Where the cost of the like benchmark itself imposes on the benchmark. But in this case, doesn't really matter. Like, it just doesn't really matter too much in this case. Okay, so now we have that. And then we can print the same thing at the end. And sound goes. Any errors here? 4 over 3, 4 over 3, 4, which is Denny over Benny. Denny over Benny. So Denny's at the end, and these are kind of in roughly descending order. Oh, that's not total, that's mins. There we go. Mins 4, mins 3, total 4, total 3. There we go. There we go. Okay, so we can see the total is kind of the average across all of them. It's the sum of all the mins, which is good. So yeah, about 17.9%. So we could make it, actually, I'm gonna invert that because I want this to actually be the speed up factor. So this is now gonna be a multiplier. And we'll just qualify it there with the print. Okay, 5.5866. Let's see how reproducible it is. 5866. 5.58. So we're like, we've got like three sig figs of signal there. So honestly, anything down to like the 100th is honestly like probably relevant information here. So, so basically, this is like the maximum possible speed up that we can get compared to Benny's, assuming that whatever algorithm we do reads the inputs in a byte at a time, right? So, let's transform the inputs into an array of U64s. We'll try all the different uages. So we have like best case over Benny. with 1 byte axis. We'll just say the U8 axis is, let's say 5.58x, right? And then we'll do let input is equal to, this is going to be a slice of U16s for 2048. And then we'll do imp as pointer. Can I do as pointer here? I think I can. As a pointer to a U16 2048. Something like that. I'd make this stuff more templated out if we were going to do it. So now we can see that with U16s, we can get a 10.93x. Right, you can see what we're doing here. And eventually we'll just saturate memory bandwidth or cache bandwidth. Actually, what are these cores? These are Cascade Lakes. 3232. 21.26. I'm just truncating, I'm not rounding. Just less work in my head. Oops. Let me know if I do any math wrong, but I think I've been good so far. 64, 64. Yep, this is correct. I know this is correct because that's a page table. $38.83. Okay, so we're still going up. I don't know what Rust does for U128s. There's a chance that Rust generates shit code for this. But we'll see. Also, we're not heating to alignment. And there we go. We basically maxed out. Which makes sense. Try SIMD types? Yeah. There's a little bit of noise on this, but it's fine. But yeah, we can use core SIMD. SIMD. I think this and lanes. Like that. Yeah, I think so. Nice. All right. Pull up docs. I think I can size up on that. So we can do this. Okay. Oops. that not const time? Fuck. How the fuck do you do this? I mean, I can just say 4096. I don't think there's a way to get that constantly. Oh, whatever. Okay, 5435. And that's maxing out my lanes. Do you use your own OS for vuln research? Yes. Traditional. Well, really depends what stage of the vuln process I'm in. When I'm fuzzing, I pretty much use my own OS. When I'm doing research, I'm just usually on whatever I'm actually finding bugs in. So it really varies. U32X16. Okay, and that should be the same as a U8 64, if you can do U8 64s. Oh, you can. For a while, you couldn't do 64 lanes in Core SIMD. And yep, 5420, that's identical. So let's go down. So now we're going down to a 128-bit, or a 256. And that's not actually saturating. So we actually do want to go all the way up. We want to use the whole 512. Okay. Okay. 50, we have the theoretical maximum possible fucking gain that we could find here is going to be a 5427X. And that's assuming everything's constant, no comparisons, nothing else. So that's kind of our buffer room, roughly. Kind of that table. U256, I'm not going to note because, or we'll say U8 by 64. Because it kind of makes more sense in this particular case. Severini, thank you so much for the 17 months. Hell yeah. All right. Be right back. I'm going to top up my water and check on All right. All right. So, your current code doesn't short circuit, so it can be faster in theory. Yes, but the cost of um the cost of checking for early exits might be too expensive. I think ultimately there will probably be an interval where you will want to be unconditional, like a maybe 128 or 256 bytes that you chug, and then at the end of those you check if you exit. I know that sounds counterintuitive, but you have to check for an early exit every byte. But you could potentially, there are like some different algos that you could use if you just blast through that shit, have a value that you like latch once, you only set it once, and then on some interval that's not every byte you detect, you check in. Which is kind of the logic that I would be looking for. So, we have SIMD pulled in. I'm not gonna burn my mouth on this pizza. So we have to detect 14 bytes being different in a row. Do we have any fun tricks that we can do to do that? We have a reduced but disjoint set of characters. Since this is disjoint, we can't really do anything with that because converting it to a compressed set would be more expensive, and pre-processing is cheating in this case because this data doesn't make sense to pre-process. Like, I'm normally okay with pre-processing data into a different format when like doing optimizations, but in this case it doesn't really make sense to pre-process this data. So there's really no reason to do that and try and claim even more of a win. So let's see. That was good. Yeah, it's pretty fucking good. Oh yeah. Actually cooked perfectly. Core SIMD. What type of algos could we use here? Is include bytes cheating? No? Let's just getting the data in. Hmm. Interesting. Um. 512 bits is more than 14 times 19 bit mass? Yeah. So, I don't think there's a good vector rotate that's cheap. Hmm. Um. I'm just gonna print this. And then we'll break after the first one. Yeah. Yeah. Hey, Desu, thank you for the 32 months. Toodle 5. What are your thoughts on Glide Sort? I haven't seen it, haven't looked into it. Not familiar with it. Oh, one of these is failing. It looks like Zenny is failing. Zenny is not always correct. I don't know if Benny's still here, but this one is not always succeeding. I think it's safe to say that Naive doesn't have any bugs. And this literally, Naive doesn't have bugs, and Naive agrees, Primogens agrees, Benny's agrees, and Zenny doesn't work. It doesn't find it. I'm not really going to debug it, because I don't really give a shit, but it doesn't really work. Oh, it's also wrong on this input. Yeah, sometimes it can't find it. Sometimes it literally just gives the wrong fucking value. It's fixed if you max it. Nope. Nope. Doesn't fix it. I don't know. I don't really care. I'm going to just replace that with I'm just gonna replace it with fucking Prime. Just to fill up that slot in mins. To not confuse myself. Just turning it off so we visually don't see anomalies that aren't caused by us. Those all look good. Fuck yeah. Okay. Um. Hmm. Hmm. So what could we do here? Unfortunately, it's not like very smart. But I could literally just pull in into a 64 byte SIMD register. I could pull it into 14 SIMD registers and just compare them. Pizza's gone. I'm fucking hungry. I'm fucking hungry. I got another slice. It's okay. It's very Italian. Made by Mario and Luigi. Um. Hmm. With mushrooms? Nah. I don't like mushrooms on pizza. Hmm. 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 Um. I do like pineapple on pizza. I think that works just fine. Hmm. Hmm. U8 times 64 is 51 14-byte windows? U8 times... Hmm? You mean U64 times 64? Or are you using, like, the register bank? Pizza is really good today. I guess I was hungry. Um... We need to come up with a strategy to try. Rotate lanes left and rotate lanes right. So basically, I need to pull in the input. But how would I compare the register? I don't think there's SIMD pop. There actually there might be. Um, 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 um. Yep, there are. There are vectorized pop counts. So, what about an implementation that maintains a filter like Benny's solution but jumps variable amounts forward? The problem is that that conditional compare is probably too expensive. Like, we have to make this more into a constant time problem, in my opinion. Could be wrong. I could do that with some granularity. Um, There's a kind of a hard problem. Like, how do I compare those bytes with each other? Let me see what I can do for gather perf. What if you leave 3 lanes open and search with 2 left shifts? Like shifting the whole vector? Are you allowed to use any language? Yeah. Hmm. Sadly, you can't shift vectors. You can only shift lanes. There might be a 128-bit shift, but there's not a 512-bit shift. You can do, like, lane-based rotation, but it's not free. Today's problem can be solved with regex. Cringe. More like Desu cringe. Problem is I have to keep track of uniqueness. And that's not fucking easy. I think I have to do like the Benny Bit thing. I don't see another way to... Right? 32. Do I see another way to handle that? I don't think so, because I have to keep track of... I have to keep track of all observed values in a 14-byte range. And I don't know which one potentially is repeated. Like, I can't predict which one might be repeated. Which means I have to store all of them. What can I do? Oh my god. Almost done with the pizza. Or you have to keep track of indices of last 32 observed values. Yeah. But I feel like that'll be shit. Maybe not. Maybe that would work. We gotta be able to come up with some new algo here. Something creative. My idea is to jump to the max of one after the second to last repeated byte. I think I could loop the data multiple times. 1, 2, 3, 4, 5, 6, 7, 8, 12. 18. 18. Oh, can I do this in one pass? Can I almost want to make like a hashing algorithm. Can I do that? Can I make a 4 or an 8 byte hash? The thing is, memory accesses are slow, but if I can make a hash, ideally I can do it without even a table. Ideally, I can find a cheap transform to do to all 4 byte values that will tell me if there's a duplicate. Alphabet is only 5 bits. Yeah, it's hard to subtract though. That's expensive. That's another op I don't want to do. Like, one thing, one way to think about this is if let's see. Actually, wait, does that work? I think so. I almost want to just try and make like a random hash. Can I do that? Here's what I'm thinking. All right, so input. So let's imagine that I have all how many possible inputs do I have? Let's do that. We're gonna do nutty shit. This is what I wanted. I want to do nutty shit. I don't wanna optimize an intuitive thing. I want to do some nutty shit. How does that sound? Does that sound fun? Is everyone on board? Okay, cool. Good. You didn't get an option. Do you see the nutty day 2? I haven't done any of these. This is the only one I'm doing. I don't really do advent of codes. 1, 2, 3, 4, 5, 6, 7, 8, 9. Why do they have to do that? That's Big Dickens. Big Dickens. Okay. Combos is equal to vals.len how 4. For a combo in 0 to combos, let mute val is equal to, you know, combo mod vals.len combo div equals 4 blah in 0 to vals.len. Combo div equals vals.len. Doesn't need to be mute. Say selection. Let mute val is equal to 0. Val or equals cell. Val shift left equals 8. Eh? This should produce all possible combos. Right? Compute possible 4-byte combos for each possible combo. This is the 32-bit representation of the value. This is going to be for all bytes. There's also vals. It's not vals len. That is const. I don't know. Window. Say 4. There we go. Right? That correct? Sure, U32. Okay. Okay, so, how many combos are there? And how long does it take for me to generate all those? Wow. There are 104,000 combos? That's it? Which is 18 to the 4? Lookup table? Lookup tables are good, but they're not as fast as I want because I need to do a gather. That would require me to do a gather. I don't think I can do 8. There's no way I can do 8. I keep forgetting what it fucking is. 18. Ooh, that's okay. 8? 8 is... 8 is possible. Eight's only 11 billion. That's like actually not that many. Okay, let's try the theory with 4. Okay. Back with capacity combos. And we'll do vals.push val. Striker, thank you so much for the raid. Hell yeah. How was your stream? Have some fun? Do anything crazy? I didn't see your notification, so I don't know what you were working on today. Oops. This is AVX. What's a hash function by you? What I'm trying to do right now, what I want to do is I want to not do a memory access. I don't know if it's possible. Like, I genuinely don't even know if this is possible. I'm trying to look for some math that I can apply to a 32-bit value that will give me a discernible way of detecting if there are if those 4 bytes are unique. I want something that tells me if 4 bytes are unique. Very cheaply and easily. Vals X? What? Hello? Oh, yeah, this. It doesn't know what that is. It's a U32. Question mark. There we go. We got there. Hello, bro. How's it going? Let's see what we can do. Woo! What? Oh, I shadowed it like an idiot. All right, there we go. All combos. Beep. So we should see what these look like. It should be 62, 63, blah, 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 all the way through. Yeah. So it's just counting. It's just a base, a thing that counts on that base. Can you do like U32 to that, shift 8 and repeat? Yeah, but that quadruples the amount of operations I have to do. Basically, I'm trying to find a way to not have to look at a byte individually, ever. That is the root goal right now, is can I completely avoid looking at bytes independently? I don't know. I have no fucking idea. I imagine it is faster for me to enumerate this vector of values than it is for me to recompute them. So, we're gonna actually push compute if there are duplicate characters, right? And we're gonna do this by, I guess this is what we care about right here. Cell. Mute used is OU size vals.len. Can I do vals.len here? Is that const time? Probably not. Could you reduce the size of the LUT by bit packing your letters into your character set? I don't know. That would be... Maybe. I don't know. Sure, const. U8, 18. Being a bitch is my kink. What the fuck else did I think? It's actually good to make that const anyways. Okay, glass in the midnight. Terrified. Okay. And then we'll do use cell plus equals 1. Pick the byte to use. Get the actual byte value. Advance combo tracker. Pack 32 bits together, right? I think this algorithm is correct. I've written this a billion times like this. So now all I'm gonna do is, this is just gonna be has dupes if used.iter.any x is greater than 1. Huh? Huh? Right? Something like that? That type beat? Sushi Roll is a custom kernel and bootloader. It's not running in my custom hypervisor. Okay, let's hold. Perfect. So these are all unique ones. Yeah, I mean, I can't imagine this logic is fucking wrong, right? Like, how the fuck would I get this wrong? And these should all have repeats. Okay. Yep. That looks good to me. Dupes. Okay. So this is now telling me, and then that's kind of what the data looks like. Obviously, pretty much all of them will have dupes for the first large amount. For I mean, this is stupid. This makes no sense. But let's just try something. Let's just try something. Obviously, this is stupid, right? But if result is not equal to if result is not equal to val and 1 shift. Val and 1. Sure, doesn't fucking matter. Guess is equal to val and 1 not equal to 0. Right? That's my guess. Obviously, that's ass. But I'm curious how quickly I can compute through this. How long does it take to run through this? This probably is pretty fast, I'd imagine. I don't expect this to work. Just want to put that out there. I don't expect this to work like this. But it's a concept. Okay, so that ran basically instantly. Let's see if we can go high. I don't understand how this would possibly work ever. But you know, you gotta try the dumb things. Yep. No matches. I'll try this. For position in 0 to 32. There's no reason this should work. This is a stupid idea, but it's fun, maybe. Next. But like theoretically, what I'd like to do is find some mathematical transform that I can do on this very specific set that is constant time and gives me like literally just tells me whether or not it is successful. Let's try this. Depth this dot iter dot enumerate. The only reason I'm doing this is because I don't know how math works, okay? If depth is greater than best depth is depth. Print ln record. I don't think we're making it even into the hundreds, to be honest. Yeah, 362 out of 100,000. Yeah, so like obviously this is just not going to work. No surprise there. So what we need to do is we need operations that can mix bits around. Multiply is one of those operations that can do stuff like that. We don't have a large budget for a hash. Let's start higher. Yeah, 362. Which is honestly better than I expected, actually. What if I do window 2? I can do window 2, right? I can do that. Changing the window. Has that affected everything? Obviously, it's still a 32-bit thing. What if we do this so we guarantee a carry? For some watching Gamoza? Hell yeah! Welcome to the stream. We don't know what we're doing, to be honest, right now. Really? Really? I'm like actually really surprised that it can't get past 19. Am I just dumb? Am I doing something wrong? Let's just start with this. Let's go back to the basic ones. Make sure I'm not being dumb. It's not equal to guess. In this case, position is just going to be 0. What? What? It doesn't even get 1? What? Okay, what am I doing wrong here? It can't even get 1? What? Ha! What? I guess it can't get 2. Really? I'm doing something dumb, aren't I? What the hell am I doing wrong? Or is it with my generator? Oh, it's harder with 16, isn't it? There should only be 256 dupes. Alright. These should all be 16-bit integers. I don't see why that wouldn't work. No, they're only not 256. Yep. 3, 4, 5. Yeah, that logic is working. Okay. I guess the first one's like hard to guess in this case. Okay. How do I mix that value around a bit? Are you planning on hashing only aligned U32s? Yeah. Huh. Huh. I mean, this is a stupid idea. I don't understand why add would do anything here. Because an add's not gonna shift bits around. Can a sub? Can a sub do that because it does borrows? A sub can pull in bits from above, but an add cannot. Yeah, it never gets to too deep, which is fine. Whatever. I'm not losing sleep over it. Feel like shit. See how it is. 362. What do you think that is? Yeah, I want to detect a dupe in a 4-byte window. Map 2 bytes to a LUT to a filter with 2 bytes mapped to a U32 and their bit XORed. Take chunks of 7 U32s, XOR them together for the final filter. Yeah, like, I want to do something on 4 bytes because even going down to 2 bytes is really capping my possibilities, I think. Actually, a lookup table on 2 bytes is probably not worth it. Because the access of that gather is going to be really expensive. Like, I think to justify a memory access, I need to do like a 4-byte lookup. I think. I'm talking on my ass based on like gut feeling and past experiences. But that instruction is going to be hundreds of cycles to do a 2-byte lookup. Yeah, same idea with 4 bytes. Yeah, that's in my head as like a thing that would definitely work. The question is, like, I'm not concerned that there is a lookup table optimization path here. I want to find one without a memory access, without a scatter gather. Like, I want to find a hashing algorithm that is cheaper than the memory access, such that it's not worth using a lookup table, that ends up somehow giving me a pattern that allows me to cheaply, like some hash that I perform on a 32-bit value, that for these 100,000 inputs produces that truth table. You need extra processing every time there's 2 adjacent hashes with no dupes? Yes, but that is going to be, I would say, pretty rare in the grand scheme of things, right? Like that has amortized the cost of the more expensive, like check everything comparison radically. Because the percentage of things that will pass 8 bytes being unique are probably very few, right? So the goal here is that this would be a filter function that would allow us with a granularity to determine whether or not we want to bother with a more expensive operation. And we can pre-compute this on the entire array first. So we could literally pre-compute this on the entire array in one sweep without conditional operations. So we just consume the whole 4K, do the operation on it, produce a table of the results of that, which is now compressed down to, that turns 32 bits into 1 bit, right? So it gives me a 32x compression, and then all I have to do is search for 2-bit patterns in that, and then like when I find those 2-bit patterns, then I actually have to like do more. I think that's my theory. That's like my current theory And if I could do it with 32 bits, I would imagine I could do it with 64 bits as well. How will this detect the unique 4 bytes if they aren't aligned? It won't. It won't. It's a filter. It is a very cheap first path to reduce what I have to explore on a second pass. That's all this is for. But I don't think this will be possible with, like, I don't even know, like, what kind of operations I could do here. Should we just, like, think through this? Okay, let's unconditionally... We can unconditionally get rid of these 2 bits, which increases the entropy density of the set bits. Because these set bits are unconditionally polluting and adding some extra bits here. So let's get rid of those. So we can end with 1F. It'll just clear those off. So let's do that. Let's do valmod and 1F. Because we can make, like, a bit string and pop count that, and I wonder how fucking unique that is. Like, I genuinely wonder how, like, obviously there are dupes where they're the same amount of, like, bit set, but... Let's try val and 1F, 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 right? So we are increasing the entropy of the bit string, in my opinion. Obviously, we have more zeros. We're increasing the contribution of a set 1 here. Obviously, this isn't gonna find shit, but let's see. 8. What? What? I'm really confused how we're not getting 2. Oh, what the fuck? What did I break? Hello? Oh, it's just failing. And going to the next one. It never succeeds? It never succeeds? Not a single time? What? What? Noodle mixing sound? I love that name. That's a dank name. What if I do like a top bit? I don't know why I'm just trying. Okay. 362. That's interesting. That's interesting. That's intriguing. That 362 is back again. 374. Okay. Obviously, I can rotate and OR them. I can do that. I can XOR them. I can... Is there no crazy thing that I can do here? There's no magical shit that I can do? I can't just, like... That? Like that sort of shit? Let's see. No, 360. Oh, wait. That improved. What is this song? It's fucking hilarious. Ash Nico. She got some bangers, dude. You can't handle Ash Nico, dude? Song goes hard. Ding. Do you have any other brilliant ideas here that we could do? Okay. I'm trying to use big brain right now. But I'm not finding any big brain here. Okay, what if this were like uber dense? We have 18 values, so they fit in 5 bits. So let's shift it by 5, and instead here, let's just use the actual selection. So this is now a super dense bit string. And it has to be above all of the bits. Oh, we don't want the and. Top bit, top bit. Obviously, this function would not work. Like, this doesn't make sense. Hmm. Hmm. Whoops. No, not dupes. Val. The dupes are the ones that we need to detect. Okay. Okay. Hmm. Oh, do I have AVX-512 bit elge? I don't think I do. I've got bit elge on this computer, but I don't think I have bit elge on my. I don't think I have bit elge on my server that I'm running on, which is tragic. Yeah, that is 2 3s. Hmm. Is there? How do you even like find this? That with that. Could a soul like Z3 help? I don't think Z3 can give you formulas. Like, you can't say find a function that does this. I mean, it would have to be a pretty smart bit trick, I think, for it to work. Dot, dot, dot. I don't think it's possible without rotates and shifts. How expensive do you think my gather is? My gather can go up to what? How much hex? Isn't it 18? 12. What? What is the largest number here? 7A? 7A ended with 7A and 1F. Oh, can I do and here? Can I do and? Oh, there we go. That's 1A. So these will go up to 1A. 1A. Okay, so what is... What is that? Hmm. Okay. 1A. 437 million possibilities. $437 million. We can't do a lookup, I don't think. We can't do a lookup on 4 bytes. There's some kind of property of the pop count that's invariant if you have more than one matching byte. That's what I'm kind of curious about. Like, just weird shit like that. How much faster is Benny's if you don't branch? I don't know. I'd have to port it. I kind of don't want to. Fuck. Let's just turn this off for now. See what happens. Oh, wait a minute. Wait, what? Oh, what are we doing? Oh, I must have added another global. Yeah, these values went in front of that. Okay, so it's that code existing. Oh, maybe not. Oh, I should also disable SLR. What if you use the compress instruction? Hmm. What's interesting is I think this would actually work well on the Xeon Phi. Um, I might be able to use CD. I don't think I've ever figured out how this instruction works. Is there an Epi 8? No, only Epi 32s. Let's try. Oh, yeah, there's only Epi 32s. Shit. Hmm. What if I did 8 at a time? How expensive are random accesses with a gather? Put this code back. I do have Mole High. Oh, that's Knight's Corner. Is Mole High only Knight's Corner? No way. That's a scam. Hmm. What the fuck? What is this? This does horizontal operations. What the fuck is this? Bruh. This does horizontal operations. This is a horizontal ad. Is it not? What the fuck? Compared to those in B and store the result in death. It does horizontal addition, but not horizontal comparisons. What happened to the camera? Do I not have a battery plugged in? Is it not charging? It must not be charging. Rip camera. Um, This is really interesting. And this is not something that I ever think exists in 64. Is this not a horizontal? Can I not use this for a horizontal 8-bit add into 32 bits? Right? Is this not a horizontal add? That's fucking insane if it is. That's crazy. What? This is beautiful. Okay. Let's do, DB sad. All right. Surely there's a catch? I'm not seeing one. Let's see. Let's see if I can get this to do anything fun. Can I pass in SIMD values? U8 by 64. I'm in London shopping carts. Right around. Yeah, yesterday we'll make the escape. Won't hear what they say. This is also a broadcast. This is really cool. This is really cool. Hope as always well. Thank you, Rebel Elder, for the 22 months, and Jan Pollock for the 26 months. I don't know if I shouted out Jan. Thank you so much. Glad you enjoy the whatever this is. Escape, don't hear what they say. Is it not VREG? Ah, nice. Throw it away, forget yesterday. We'll make the great escape. Won't hear what they say. That is a SIMD vector. Mm-hmm. Can I do into on this bitch? Yes. Charlie Boy, thank you so much for the 5 months. Perf. Into. We'll do SIMD. How do I want to describe this best? M512i into. Holy shit, 24 months? Hell yeah. Not EU friendly? What do you mean it's not EU friendly? You're not EU friendly. That's standard simmed. Okay, we're getting there. Hey, we have compiled code. Let's out. Then we'll do out zmmreg out. Say ret. Here we go. 5 minutes to midnight. This should produce 0. SIMD U8 U32 by 16 from temp. I don't know. I'm just talking on my ass, chat. Okay. I don't know why you think I have any idea what I'm doing here. Ret. Come on, let's go. Let's go. Let's do this. Let's do this. Fuck. Is it the B? It doesn't like the B's? Is it that? It doesn't bzzz. Doesn't like the bzzz. Yeah, it's the bzzz. Midnight. What is that? That's E? That's E8? Sure. E8? Zero. Perfect. That's what I expected. Let's do temp 2. Oh, let's go! Let's go! Let's go! It's gonna fucking work! Temp 2, splat a 0 into that bitch. Now this will be... fours? The fuck is that? Loving fuck. Oh, these become 16s? They go into 16s. To midnight. Let's go! Holy shit! What is that instruction? Oh my god! No! No way! What the fuck? That's... What the fuck? Zorg, thank you so much for that 19 months. Hell yeah. Technically, it doesn't matter what this immediate is, because they're not using the second arg. We could just pass in 0. Not that it matters in this case. Okay. And it's horizontal difference sum of 4 values into those. Now I'm running and scared. I feel like I can actually do something with this. Whoa. What if you give... Oops. Yes! Okay. 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 Oh my god! Holy shit! Oh. Let's see. Let's see. Oh. I think my power supply for my camera sustains if it's doing 1080p, but not if it's doing 4K. I think that's literally what's happening here. There we go. I think that's literally what's happening. I think I had it in 4K, and I think that literally just it's just a smidge more power, and it just isn't self-sustaining. Well, this is fucking crazy. I can horizontally compare 2 bytes. But does that get me shit? Does that get me anything? And I think the answer is no. Right on top of the world. It's still something I never was able to do. D word. +1, plus that, plus that. Let's go, let's go down to fewer lanes for now. Let's go to zms. Unperfing. Perf minus minus. But it's just the same thing, easier to visualize. Unlike any other, be my thunder. Yeah. So this tells me that the top 2 bytes match. Which is fucking crazy. All right, if I were to make all of them match, I think I just get zeros across the board here. Yes. And if I make just one not match here, and yeah, those are 4 apart. If I had like 6, 2, we would then have a 5 in there. Unlike any other, always be my thunder. Let's do this. We're making progress, chat, okay? Just put all 18 in there. I swear we're making progress. We're learning things. Not new? From array? Oh, I just do from array? Okay. I think the 240 gigabit of USB is really chatty. And you should keep being chat. It's definitely exotic. I'll give you that. Wait. Is that one always going to be a 0? Okay. Now we got to think again. Chat, put on your thinking caps. I don't have their thinking caps on. Oh, I did the binary wrong. Oh. Oh. E4. Knight to E4. Okay, that makes so much more sense. Does it? Okay. Okay. We do that. So we do that minus itself, which is guaranteed to be 0. That minus itself is going to be 0. The first one will always be 0. The second one... The second one... We have thinking caps. I thought chat was incapable of thinking. Huh? What is E4? It's selecting the array indices, and I'm just doing a 1-to-1 mapping of 0, 1, 2, 3. So that's 0, 1, 2, 3 in binary. If they're all 2-bit, if they're all 2-bit fields in the immediate. So the first one I don't care about. This one I do care about. My brain has been confiscated by a 2-letter agency. Yeah. I mean, I think a 2-letter agency probably could handle that pretty easy. Definitely don't need the 3 letters for that brain. Does this agency have any duplicate letters in its name? My medication. Okay. Rewrite it in Rust agency. Chat, raise your hand if you're ready for what's about to happen here. Good, because I have no fucking ideas what to do here. I think I can cast. Okay. We did a casting couch. Okay. Oh, my dad. That's not casting. That's... Fuck. Oh, can I just dot into? I think I can just dot into. Okay. We're gonna do a SIMD. 4. Sim these nuts. Really? Can't do that? Is Sushi Roll public? No, it's not. Okay. I don't. This is probably not correct, but we're doing it. There's probably a better way to do this, but I'm not gonna keep reading docs because reading docs is for nerds. U32 by 4 is equal to temp into. God, I'm smart. Fuck yeah. Let's go. Let's go. Plus. Read between the lines. Bear me up against the wall. I don't know the lyrics of this song. Oh, what a little bitch. Man, Russ really doesn't want to cash it here. I think that's good. Right? Right? U32-4. Shift 16. Big brain here, big brain. Big brain. That. 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 I was on the screen 4 hours ago. Did you write the network driver? No, not for this. Wait, what? Wait. Mom! Am I dumb? Do I not understand how computers work? Fuck. Can we do that? Wait. I might be dumb. Why am I adding? Why am I adding? Fuck. I don't know how computers work. Ah. That, and that. Whoa. Okay. There's logic here that exists. I'm not coping. This is not cope. Yes. 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 Fuck. What? Oh, mommy. E4. Still E4. E4 is correct. E4. We want to ignore those. And we do that by that. That we care about. That is the information that I want to get, which has to be 2. Well, that might be fucking useless. Ugh. Can I not abuse this instruction? I'm getting scared. I'm quivering in my boots. Is it not possible for me to do? Can I not? Can that not do that? Need a splat emote? A splat emote would be good. Okay. Hmm. 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 Shifty, thank you so much for the 5 months. Hell yeah, brother. Let's see what we got here. Desu backseat. Okay. Does this mean anything to me, to you, to anyone right now? Does anyone find meaning in any of this right now? Because I don't right now. Shit. I feel like I can do something with this function, this instruction, which is a function. Subtract. That. Can I get an FFFF in chat? I thought I could do something with this, but I don't think I can. It does allow for horizontal addition, but then we lose the signal in upper bits. So it's kind of pointless. Which makes me sad. Makes me want to go, wah. Very DB Sag. Mm-hmm. Mm-hmm. Hmm. I swore I could do something. Like, I can cause this to do a horizontal add, but then these just overwhelm it. Seven to 15. But then this uses 15 from A. So I'd have to remask it. And that's the same position that I want to use. One to 8. 16. Hmm. 4 sads are produced. Yeah. One. Um. Hmm. Nerds over at Intel designing and creating those absolute nerds or chat. They're nerds. Definitely nerds. Hmm. Hmm. So the quadruplets are the same A from both. 2. I'm pretty sure I can abuse this. Right? The absolute value kind of blows chunks. Can I get a non-absolute value version? I think if I can get non-absolute value to this, I can maybe make magic happen. Hmm. Nothing's jumping out at me like, use this. It's good. So this first lane is useless. That will always be 0. Right? The first lane should always be 0, assuming I don't do this. If I just do this. First lane will always be, it's not 0. What? Oh, because I'm doing this. These are 16 eighths. So let's see. This is going to give us all of the information that we extract from this instruction. (05C6) 0595. So the first one's always going to be 0 with this current variant. Let's do chat. Remember E4. Oops. 1 1. What's 1 1? 1 1. Set 5. 55. Hey, Cybergenic, how's it going? Okay. Okay. E5, you sunk my battleship. How does this work for the big boys? M8 repetition. Okay. Repetition. DM'd you on Twitter? Ooh, okay. Yeah, I haven't checked Twitter DMs in a hot minute. I will try to remember to do that. Oh, how do we do this, chat? $17. From gray. Yeah, let's stick with E4 for now because I understand it better. (5C6). Boom. We don't care about the 0. The 5. The 5 is this. 5 is 0 plus this plus this plus this plus this. That on itself, this. Right? Is that true? 2, 2, 4. That's 4. 62 minus 62. Difference between these two is 2. It goes up to 31. What? Why can I not read this instruction for shit? Have we not run this new version? I think we have. Yeah, that's the latest. Okay. 16, 0. This one, 5. Okay. That should be... This 62 minus 62. 62 minus 64 is 2. Oh, no, it goes all the way up to 39. Yeah, okay, okay. 1, 2, 3, 4. 1, 2, 3, 4, 5. Yes. 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 That is the progression. But we go to 32, which means we want to source that. Fuck. Um, 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 um. Oh, is it then a 2-gapper? No, then it's this over this? What the fuck? This to here? Oh no. Oh no, it's over. No, I don't think it's... I think we can use this instruction. I think we can use this instruction. It's just sophisticated. If this works, it will be the dankest Dankerton in Dankville. Then that's a 16. That goes up. 1, 8, 16, 24. 8, 16, 24, 32. 16, 24, 32, 40. 24, 32, 40, 48. Okay. So those... That's a window. We have a window. Then we have to A. If we do A... Oh my god. Oh my god. Oh. That. So that quadruplet stays in place. So we do a sliding add of diffs. Which is why that's always 0. Here's what your Rust solution looks like. We don't have a solution yet. Okay, I'm gonna manually do this. 62, 62, 64, 66. All right. Okay. This is now important. Yes. Yes. I think. Miss that smooth head? Yeah, I gotta shave my head. Uh... Uh... Oh, this is fucking wild. I think this worked. That. Diff that. This doesn't have that, but has that. But I need that. Fuck. Ask ChatGTP to solve it. It's trying to beat my solution. Ah. I E4 temp D word. I'd love to see the perf numbers on Twitter. Is the goal to detect if we have repetition of 14 bytes in a 16-byte register? I mean, that would be great. I don't think we can do that. The first one is 0. That makes sense. The second one is the differences between the neighbors. These two, these two, these two, and these two. You should have an 8. That 8 is because that's 2 plus 2 plus 4 is 8. And then C. So it's doing a compare. It's comparing that slice with this slice. Then it's comparing. So it does this compared with this. Or it does this compared with itself. Then this with this. After that, it goes to the next 64-bit pair for our version of caring. And then does this and this. That's really weird. That with itself? Then that with itself? Up to 39? Oh, wait. Then it goes with this to here? Yes! I don't know. I think it could be useful, Dasu. Bam. That. Fuck. That with itself. That. With this. Then this. With this. this again with temp starting 24, which is this? What do we do, chat? What do we do? This looks tragic. Upper 8 quadruplet? Upper 8 bit. Lower 8. The last two sides. The upper 8 bit quadruplet. Quadruplets from B is a B. Look for less esoteric. But this is great. This is great. There's math here. There's silicon in my processor that can do this, and I want to extract the data out of those transistors. I paid for all the transistors and I'll use all the transistors. Exactly. God, is there really? I can't, because it muddies the water. It muddies the water. What are those? No matter the mental cost. I don't think I can get information out of this instruction. Oh, it literally does so many horizontal arithmetic operations. It does like everything I want. But then it does stuff that I don't want. I just want it to do the stuff that I do want. That's all I want. Rip camera? Yeah, batteries not sustaining for some reason on whatever I have it plugged into. Fuck. Are we screwed? Is computing over? If it was and or min and not a sum, it would work. I know. I know. I'm just wallowing in sorrow right now. Found another CVE? That's illegal. I'm so DB sad right now. This was going to be the hero instruction. DB fucking Sag, dude. DB Sag. Fuck. Here I thought my computer was useful. It's over. Everything we ever did is for nothing. Okay, so is this getting mad because I'm going to Denny's here? We need to stop going to Denny's. Yeah, it's just going to Denny's is the problem there. Okay, so going to Denny's here. And that's pretty obvious what the issue is there. So let's see if we can cure that. I think we can. Does that have to be a referee? Include bytes. Oh, I can do that. I can deref it. Oh. Ooh, baby, love the way. The carpal tunnel. Let's go. This is big. This is big. And this should crash. Okay, cool. Crashed. Big cool. Nope. We're gonna do like struct page. And then we're gonna do a repr align. Oh, we should also repr C that. I mean, it doesn't really matter in this case. Repr C align 64, 69. Honestly, let's just give that a straight 4K align, boy. Yo, let's go. Let's go. Replace that with one of these. And then replace this with one of these. Hello? Oh. Okay. Okay. Let's go. Big, 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 big. Big. Raise your hands if you're excited. Raise your hands for Pog. Put your hands up for Pog. There we go. Good. All right, now it won't crash anymore. Oh my god, I'm so fucking smart. Unreal. And we didn't even build it with AVX-512F yet. That's now a 65X. Let's go! Let's go! Let's go big! Big! That's what I want to see! 128? 128? Or, what's 154 divided by minus... Yeah. Is it, 34? 28? No, it's 26. It was 26. 128 over 4096 divided by 64. That's 2. That's two cycles per. Is that perfect? Is that perfect? Yeah, raise your hand if you think this is perfect. Why am I on this? I want to be on WikiChip. WikiChip! Hello, WikiChip! Gimme it. Gimme, gimme, gimme. Oh, yeah. Oh, I have 3 UPI links. No, yeah, I do. Yeah. Oh, yeah, of course I do. Okay. Hmm. 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 Why is this so fucking slow? Four thousand 96 divided by... That should be 64, I would imagine. Go to bed, Geek Pirate, and enjoy your brain surgery or whatever. Maybe they can put one in there. Oh, shit! Get it? Ha! Got him. Got him. Got him. Good lord. Hmm. Why is this so slow? Did we see what kind of garbage ass code gen we got from Rust? We can see what kind of garbage-ass code gen we got from Rust. Son of a bitch. Maybe hide the camera? Hmm. There you go. Does that help? You must be mangled. Fuck. Oh. Damn. I guess my little trick to put dwarf symbols in a PE doesn't work anymore. That's sad. Sad AF, to be honest. Hmm. Well, we can just look for ZMMs. Here's the function. Oh god, we're looking at shit assembly. Okay, there we go. There we go. And yeah. I mean, that's pretty optimized. Oh, are we getting zuppered? Is that why? Is it the zooper? Are we getting fucked by zero upper? No. No. No, that can't happen. That would be a scam. Not V0 upper, is it? No, don't think it's that. What am I doing wrong? Because this code gen looks fine. Hmm. What's going on here? Maybe I'm just not getting up hot enough. Yeah, I'm probably just not getting hot enough in that. Probably not. I'm probably just not hot enough in the cache. I don't know. It seems pretty far off. Not happy about it. Okay. Let's think about exotic implementations that we can do that are slightly less exotic than the exotic one that we were going to do. How does that sound? Losing street cred. Yeah, I'm not happy with this problem. There's gotta be a creative way to do this, right? There's gotta be a creative way to do this that isn't shit, right? All right, let's see what the throughput is. VP gather. Double D's. That's the same instruction. What? What am I missing? $30 cycles? I bet there's a super elegant way to do it in Lisp. Fuck Lisp, dude. That language sucks. That language is for communists. Name one good thing about Lisp. Bet you can't. Bet you can't. Syntax. Yeah. Yeah. Super. Best thing about Lisp was that it's smiley with a lot of parens. Is it worse than objective syntax? No. Hygienic macros are well, Rust has that. Rust has it. Oh shit. What are we gonna do here? What kind of design do we want to do? Because I don't think we're gonna find any magic shortcuts. Okay? Chat, so take off your shortcut hat and put on your suffer hat. Because we're gonna go into the suffer bin. You ready to suffer, chat? Okay. 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 Raise your pog champs. Because we're going in. I've been designing algorithms in my head this whole time. So even though it looks like I haven't been doing anything and I've been just fumbling around with stupid ideas, I've actually been coming up with some of the most brilliant strategies that I can have for strategos. Okay? So I actually have really good ideas. Okay, let's do 4096 times 18. Shit! Hmm. Hmm. What if you just hot path the AVX sad instruction by looping it on a background thread and pipe in the real data after a bit? That's true. That's true. Just keep my CPU chugging. I'm picking up what you're putting down. That makes sense to me that I would want to do that. So, what are we gonna do here? Okay. 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 All right. All right. Okay. Um. What? What? Did they make an equal trait? Um. Oh, they did. Good night, Zena Bueno. Do int? No. No. Pass. No. Hmm. How do I turn a mask into an int? Can I not do that? Um. Hmm. Is there no way to shit? I can't turn a mask into an integer? This is a problem. Are you fucking serious? That's fucking dumb. I wanted to use SIMD, but we might have to just use intrinsics ourselves manually, which is kind of shit. Does Rust even have all the intrinsics for AVX-512? Yeah, I think they do. Okay. So I guess we'll just use use core arc x8664 everything. Use everything from there. We're gonna cast this into an M512i. Got 2-bit mask. That's a thing? Oh, do you have to turn on like all? Will I have that? Not in my docs. Please exist. Okay. Maybe a good sign so far. Is that only enabled if you have AVX-512? Oh, it's 2-bit. Oh. It's a trait. Okay. Okay, good. Okay. Ah, that's tricky. They hid it in a trait. Yeah. Yeah, there's just, it's so hard to look at the trait implementations because there's so much fucking implementation here. Isn't 2-bit masks shit perf? Might be. We'll see. Mm. Int. Need to enable pop count? Probably. Hello? Oh, I cast it. Oh, okay. Yeah, duh. Duh. Long time no stream? Yeah, stream? Yeah, it's been a hot minute. Mm-hmm. Mm-hmm. Put some B's on these. Comma B this. What do you write your OS in, Rust? Mm-hmm. For char and that? Yeah, that probably would work. You don't like this? You don't like this implementation? I think you're jealous. Beautiful. 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 Okay. Is this just gonna get completely optimized out? Higher level languages are fun. Never. Ha, never fun. Is it in my veins? Optimized out. Okay. Ass. Ass. God damn it. Shit. That was my brilliant idea. Let's see what kind of... Okay. Okay. Let's fix this. Fucking kidding me right now? Can I give it an architecture? Can I say target CPU? Is that a thing? I don't think so. I think that's not a thing. Dicks. Okay. Okay. Two eyes bored, I don't know bored. Ah. Okay. God damn it. Why is it so hard to find the fucking list? Okay. Can I do commas? Can I do this? Target feature. I think I can do commas. Woo! Yes. Okay, hopefully that does literally anything. What the fuck is this? What the fuck is this code gen? You fucking kidding me? Holy shit, I'm sick of this fucking... Calm, 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 calm. Relax, relax, fine. It's fine. It's great. It's fucking great. Fucking amazing. I love it. I love this code gen. It's fucking great. I need to write my own fucking compiler so soon. I'm so sick of this shit, man. I'm so unbelievably sick of this shit. Mm-hmm. Um, Come on. Sure, we can epi 8. Epi 8 on that as well. fine. Nice. Unless this code gen is going to be the same. No, it's way better. What are the fucking odds? Wow. What an absolute fucking surprise. Alright, where's my actual code? Wait, is this not my code? Cargo show ASM has failed every time I've tried to use it, and I tried to use it a couple months ago. It's literally never worked for me. I don't know what it is. I never looked into it, but it never fucking works. I don't even bother. I guess this is show ASM. I use like cargo ASM. This is show ASM, I guess is different. Yeah, I use cargo ASM. Okay, it might be usable. I still prefer this, to be honest. They're just gonna crash? Where is this code? Not IceBP? Wow, it doesn't know what IceBP is. Into, that's fine. That'll work. Oh yeah, it's not 64-bit mode. Int one. Are you fucking kidding me? The do that. Wait, this is generating the equivalent code for non-AVX? Really? It can do that? Okay, what? Seriously? That's what it was doing? No fucking way. Wild. Okay, that's interesting. I didn't know it could do that. Nice. So that's doing a broadcast, which it should be. And a pop count. Can't move Q. It has to do that to pop count it. Yeah, I can't pop count a mask. So this is the min set. And then OR it in. Accumulate this info. So, broadcast. Not going to be able to beat that. Memory hit there is correct. Compare, that's correct. Move Q, mandatory. Pop count, that's correct. And then we are ORing RDX and racks. Yeah. And it's actually optimizing this into an OR, and it's going to do one comparison at the end. Nice. That's good. That's good code gen. That's good code gen. Good code gen. And it's slow as shit. No, break. Oh, setting the direction flag probably also didn't help. We're not using portable SIMD though. That's the confusing part. Okay, so um let's be careful with this. Try this. Okay. Hmm. I is equal to 10. So this should be really fast. Yep. Mute. Fire is false. Fire or equals res count ones greater than 1 if I mod 1 is 0 and fire break. It should be okay. Okay, interesting. What? Iter enumerate. What? Break that. Oh, I have to put the asm here. Okay. What? That's faster than this? Wasn't it like 4? Wasn't it like 4 times faster when I did like this? 5.4? The fuck? Is it enumeration? Is that the problem? Okay, this is apparently way better. Weird. Just trust things. What the fuck? Um. hmm. I guess we can do this. Okay, let's try this. What does the empty assembly do? It prevents it from being optimized out, so it doesn't end up just doing nothing. Okay, let's try this. 8661. Okay, let's try it without enumeration, but now using constant. That's just slower for some fucking reason. Jesus. What if I don't enumerate? What if I just iter? Is it just borrowing? Borrowing saves the day? Yep, it's just a borrow thing. Okay, sure. Okay, fine. You can borrow that, no problem. All right, let's try and make this faster. Let accumulate is equal to res count ones is greater than 1. Let mute ACK is false. ACK or equals this. And then we're gonna do if ACK. This should be 852. This is the same thing as before. It should emit literally the exact same code. Okay, 844. Let's see if we can speed it up by saying if I mod 4 is 0. And this. I'm gonna actually do and 3 here. And there we go. Now we're at... Oh, we're slower, actually. Okay, interesting. What about 1? .60. I think that's just noise. Try 7. .673. Okay, so that's not helping in this case. Okay, so we'll do if res count ones greater than 1. Or equals for a bool, yeah. That's hot. Hot, hot, hot. 0.19, yep, just noise. Is this broken right now? I feel like that is running really fast. Right, shouldn't be. How is it? Oh, I put a break in there. Jesus. Wow. That's cringe. That would explain why the AVX-512 perf was different than what we expected as well. Okay. Okay, let's try this again. ACK is false. ACK or equals res count ones greater than 1. I think this is only going to be slower. If ACK, obviously this is going to do this. Okay, I and 1 is 0. 1025, slightly slower. Let's see if it gains at 3. If it doesn't, then it's worse. $9.50. Yep, so it's just worse. Okay. 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 $16. That's a 64. We can throw this in a 16. $64. Oh, I probably don't have bit elg. AVX-512 V pop count DQ. What's that in? What architectures have that? Knight's Mill and Ice Lake. Damn. Okay, so I can't do vector pop count. So, hmm. Hmm. Anyone have a link to the Benny solution? Somewhere on Twitter. Fuck. I forget where he posted it actually. What the fuck is it? I think he posted it in chat. Okay, so I was thinking like maybe I could check all the bytes, but I don't think I can do that. I'm kind of surprised. I guess it's just slow. I guess this is just too expensive here. If back or Earth as he lives, yeah, what up? Yeah, so we can't check all the characters like this. Okay. So, I just don't think this will be a super feasible thing. I mean, I guess I can get an 8x maybe by doing this, but it's just 8x is ass, man. Um. Uh. U32 8. U864 from target. Or to B, to C. Wow, so we're not getting through a lot of them much of the time. Okay. Interesting. I didn't want target. I want chunk anyways. Interesting. Beep. Brrr. I think it might be cheaper to do local compares. So this was like a really simple theory is like, can I just check all the bytes and just do it unconditionally? The answer is no. So we have to try a new solution. And let's ignore that enumeration right now. And let's try this. Obviously, this is instant. Okay. Dot files. I don't really have any dot files. Not a dot file type beat. For each chunk in the input. Okay. I think we need a VP roll V. Let's try that. Let's try an Epi 32. Yeah, I think Epi 32 is good. This is AVX-512F. Pretty solid. So this is gonna be 3 rotates. Oh, I actually don't need roll variable. Yeah, non-variable roll. Let's go. Right? Rotate that 832 and 64. 8, 16, and 24. And these are fast instructions. And then what we want to do, that and this is okay, cool. All right, let's try we're gonna roll it. which is all the possible windows. Right? That's all possible windows. Correct? And then we can do... Mask is MM512. I think we want to do byte compare. Yeah, right? MM512 compare epi8 mask. Chunk with A for equality. B and C. How bad's that one? Yeah. If mask is not equal to 0. Wow, 8x? Huh. Maybe just searching for all the bytes is faster then. Let's look at the code gen. Has to load it. 3 roles dependent. Compare to, then or, then compare. And then or test and equality. Yeah, I mean that's just max perf. If it's equal, jump 1 be 0. Add 40, compare with that. If it's equal to that, then we're done. And that will go to F8. End. Oh, we're not even early exiting right now. Oh my god. We're like stressing for no reason, chat. Oh my god. Oh my god. Oh my god. Holy shit. Wow. Okay. I was like, how the fuck are my margins so low? I thought I was like fucked. Okay. So this is cool then. I think this is doing what I think it's doing. Let's think through it. Rotate it 8, 16, and 24 as 32-bit things. I think we should maybe go to... I think we should maybe go up. We should maybe go up, chat. Four, 5, 6, 7. Let's go 64. 8, 16, 24, 32, 40, 48, 56. I'm taking. Wants to know. One, two, three, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Right? 8, 16, 24, 32, 48, 56. Yeah. This will be a O8B. I am an idiot. Wait, what? Oh, I think my panic doesn't support it. Doesn't support format strings. They didn't exist when I wrote this kernel. There weren't format strings for panics. The legacy kernel. And this is an O64B. Okay. Hmm. Is this... This isn't what I want. Is it what I want? Panic at the end? Panic at the Disco? No way. Whoa. Oh, that's cool. I benchmark my solution, and I'm so much better than Benny, and Benny's a little bitch, and I hate him? Jesus Christ, dude. You don't have to... You don't have to put it that way. Okay? Yikes. Fucking rude. You're gonna be Zenny. Let's see how you do against Benny. I mean, I don't even use that in there, but whatever. Fuck it. Don't give a shit. Don't give two shits. Let's see. I gotta turn off my Denny. We'll just say, none. Okay. There you go. Let's see how the Zenny does against the Benny. That looks a little bit better. Let's put it on the hot seat. The Zenny. Let's take a look at the Zenny. I'm seeing faster across the board. In fact, not slower on anything. Okay, so I think it's time to put Benny in the bitch seat. And now we're gonna beat yours. What is mine? Jenny? No, I'm Denny. These are great names. Not getting confused at all by the naming. Rip Benny. Well, Benny wanted to feel good. Could just write better code that doesn't suck, you know? Just kidding, Benny. We appreciate your code. It's just bad. D colon. Yeah, quite a bit faster. Quite a bit faster, the Zenny from the Benny. And you don't need any CPU flags. Is there any CPU flags that you want? Trying to think what you would benefit from. Well, we also haven't checked that yours fucking works. Okay? Let's do that quick. Before we get too cocky here, let's make sure that yours like actually fucking works. All right? Probably doesn't even work for shit. Oh, yeah, that's why we added the break. It looks like it works. Matches all the others. Everything matches. I'm gonna give you an A+. You get an A+. I should probably write something that like actually tests the results, but whatever. You get an A+. At least for this set, you match all of them. And Benny needs a modern CPU. Yeah. Yeah. Yeah, yours is just better. In every conceivable way, it's better. But no surprise there. Oh, it was... Oh. I was slower on that. Yeah, but I'm not exiting early. I need to relax. I'm not exiting early. It's fine. I need to relax. I'm getting so stressed out for no reason. Okay. So, let's take a look at this now. So what does he do? For each thing, for each byte, look backwards. Oh, this is some advanced shit. Interesting. It looks like the number of... Look at this. This is interesting. Okay? We're going to put a break in here. Remind me later that I have a break in there, okay? So when I'm like, why is this ass and noisy? You're going to be like, wow. If you get a dupe, you just skip until the dupe is gone? Yeah, that's like standard search stuff, isn't it? Okay, so there are patterns here. Their data is not uniform. Look at this pattern. Look how partway through, it gets looser. And how much you want to bet? Oh my god. Yeah, we're now like looking into like Oh my god. Look at that. Look at that. This data is not uniform. This data is not uniform at all. Is that exactly halfway through? It looks like halfway through they completely switched their random number generation. Their RNG sucks? I don't think so. I think they are doing this intentionally. I think this is to guarantee that you will always have to go like halfway through the input or some shit. That's what I'm feeling. I think that's literally what's happening here. I think fundamentally, it is impossible. They don't want the solutions to be early. Yes. It is obvious they're doing something. Very fishy. Very fishy. And is that exactly halfway through? I'm going to copy one of these blocks so we can like take a squiz at it. I would say the entropy or the patterns of ones falls off here. 29. How many lines are there total? 64. So it would, like the 50-50 split would be at 32. I could see that. This is very zero-y, but this is also pretty zero-y. I would almost say it's a little bit before that it gets pretty zero-y. But yeah, I think we can just skip the starting bytes. I think it's like guaranteed that you can never find something in the first like couple hundred. That's the only thing that makes sense. Like all of these have the same pattern. Fuck yeah. Oh, we're so smart, chat. We're gonna keep writing ours. So skip the first X bytes. Yeah, like actually? Yeah. Like actually. God, I'm so fucking good at code. How am I so good at writing code, chat? Okay. Okay, so now I have to... 8. 8. 8. 8. Okay. We're gonna do... I guess we're gonna do some... MM mask. How do I do this comparison? Also, I'm gonna put my monitor so I can see how much current my camera's running. Oh, okay. Let's see. Now my camera should work. Look at that. All right. I put a meter on it until I found the best cable and brick combo. And now it's pulling 7 watts through USB-C instead of like 3.5. So hopefully it is now beyond sustaining its battery. Pull 9 volts, 0.77 amps. There we go. We did it. Hopefully it is now usable. But it's consuming a shit ton more power, which is good. And it's taking 9 volts instead of 5, so it's more efficient, even though it's the same wattage. Higher voltage is usually just better for most things. Okay, so if mask is that, and I think what I want to do is I think I want to turn that mask into a vector now, which is kind of weird. But VP move Q. VP move Q. Or V move Q. Is there no move V move Q? There is an SSE, but is there an AVX version? Okay. CVT SI64. Is there not an AVX version of that? I mean, I guess it doesn't matter. Yeah, I think it just doesn't matter. Okay, let's try. I don't think I want to use MMX. Can I just... If I use MMX, do I get punished for that? Let's try this. Let's see what happens. This is a hack and a half. M64. I don't think I've ever done. I don't think I've ever done this. Yeah, we might have to use the SI128. CVT SI64 SI128. There we go. Okay. Now I can do a MMX ISO 1997. Yeah, exactly. Now I can look for. I want to look at bytes. Epi 8. And that is states is equal to this. Unique is equal to this. Epi 8 mask on mask. And we want to compare with a probably a set 1. Epi 8 with a 0, and then compare with 0 for equality. Right? And then that gave me a mask. Right. Right. I think I want to go the other way and drop the... I have to do the mask conversion. Mask load, mask move. Store. See what I got here. Can I directly convert a mask? I don't think so. Oh. Rotate, compare. Okay, all the comparisons. That's comparing with always. That accumulates a mask. The latency on this bad boy. Compare Epi 8 mask. A 1-1, and that's a 1-1. I wonder if I should be dropping the 0 mask. I think we can accumulate up like we're doing now. Accumulating the bits, oring them in instead of masking off and going the other way. And now we need to compare these fields. And we can compare... I guess I can peel that now. So we can say this. This is so fucking hot. Let's go SI 128 to SI 64. I think that's the correct one. Print line 08X. Wait, no, that's not that. This is a that is a mask move. That's a mask to an int. That's a CVT mask 8. U32 on unique. Actually, what does this return? An M mask 16. Oh, okay. Yeah, that makes sense. Bam, 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 bam. Mask 16. Convert mask 16 U32. What? How did I do this before? Didn't I do this before? I guess I can do a mask to int. What? Pair FE8 mask. An M mask 64. That returns an M mask 64. M mask 64. And I want to get. Did it just CVT mask? Wasn't I doing that? Did I delete that code? I guess I did. Because that should get me an int. MMCVTSDUC. No. What? M mask. I have an M mask 64. Didn't I get that mask before? Oh, the mask is already a U32. Same with this one. It's just already a U32. Okay. The top bits are always set. This needs to break. Okay. Beautiful. And it's always going to be 0 at the start. Okay. Only care about the bottom bits there. We'll just do this. Here. Bam. Bam. And this is 08B. Here we go. This is the one. Okay. So they should basically be Oh, wait, what? I think I did it wrong. Really? Oh, I'm an idiot. No, I do want FF. And FF. We should get the bottom bits. Right? Which are 0 at the start, which is what I expect. But now they're not. That makes no fucking sense. Oh, because I'm doing not equal to 0, like a fucking idiot. Okay. Okay, here we go. We're getting there, chat. Okay, so they're all 0s at the start. Easy optimization. No fields can be unique. Then we come down here. And we get to this point. So skip and go to the next sets. Okay, and then we get there, and then let's just break here. And let's just return some 1, just so it behaves differently. That will prevent it from getting optimized out. Here we go. Getting a glimpse at what could be. What we could have. The world is our oyster right now. A oyster indeed. Okay. This is a really naive implementation. I kind of don't necessarily like this one, but, you know, we'll give it a shot. So this is rotate each 64-bit lane to all 7 8-bit aligned rotations. Now, compare the original 64-bit lane with all possible 8-bit rotations and accumulate masks on equality. This will scan. Do I need to do 8 or can I just do 4? No, I have to do all 8. This will produce a bit mask which will be set for all bytes which are equal. This will produce a bit mask of all bit positions in the original chunk which have an associated I can't just skip like this. I don't think. No, I can't. I can't. All bit positions in the original chunk which have a bit set in this produces a bit mask of all bit positions in the original all bytes. Yeah. Duplication in the somewhere in the chunk. Right? So the problem is this is also looking for duplication behind you. And that's a bit of a problemo. And I think I can do this with a mask here. Right? I don't want to compare all 8 bytes with each other. I only want to compare... Right? I think if I mask these off correctly, it will work, right? Can I do that? Can I do that constant time? Yes, by putting masks here. Here. Right? If I do masks here, a la... like this. Or the other way. No, it's that way. Right? It's a mask. Yeah, I know it's a vector egg. That's fine. So... 8. Rotate left. I think I just want to do rotate right. Oh! I can just shift right. I think. Yes! Yes! Yes. This. Yes, this, right? This? Does this work? Is this right? Is this... Searle. This? Surly. Right? This is now correct and fine. Right? It's the same cost as what we were doing before. Okay, maybe not. Rotates are apparently cheaper for some fucking reason. Why are rotates cheaper than a shift? Oh. Oh, no, these are, wait. Yeah, what? What? I guess it's just expensive for 512? Huh. I mean, there's really nothing we can do. Oh, rotates are also. Well, at least rotate right. What about rotate left? No, okay. I was just looking at the 256. Yeah. All right. About to say, yeah, that would make no sense. Okay, so, I think this is now correct. Does this make sense now? Shift each 64-bit lane to all 8-bit aligned positions. I'll say combos. Shift each 64-bit lane to all 7 8-bit aligned combos. This inherently will mean that R7 will be shifted where it's only the top byte remaining over, which means that the only one that can match on that will be chunk. The first byte in chunk. And I think this prevents backward. This should now prevent detecting a quality behind you. This should only be searching forwards for matches. Okay. Right? That makes sense? That makes sense in my head, I think. Unless I'm going crazy. Right? Shift right. Which means we'll now compare the bottom byte in the chunk with the next byte from the chunk. And then this will be comparing the bottom byte with the top byte. And all the other bytes will be 0, which will never match. which will then prevent us from finding duplications behind us. We determine, we then convert that mask into this. We abuse the fact that we did 8 bits. So then we do an 8-bit comparison to determine equality with 0. And if it's 0, then if unique is 0. Oh, no, this is matches, right? This tells us which 8-byte blocks have duplicate characters. Yeah. I think I have the unique logic wrong here. If unique is 0, print ln. Inf dot into SIMD u 8 16 from chunk. 64. If unique is 0. Okay, so that's obviously wrong. This is telling us when there are matches. If I do not equal, well, we are looking for unique. Yeah, this, not equal. There we go. Are there just no fucking prints? Or did I have it right before? I did have it right before. Did I? Yes. This is saying, I want the opposite. I want this. This means that, yeah, okay. And we do get prints. And this is saying that there's an 8-byte sequence. That is forward unique. Can we do this? Is this valid logic? Is this valid logic, chat? No, I don't think so. O8B unique. Okay, so there are two. In this case, there's only one that's unique. So all these should have a forward-facing repetition. Except for this one. This one should not. But yeah, I think these only look for forward repetition. Right? Isn't it possible that 8-byte chunks miss a 14-byte unique slice? So, like, yes, but I think we can just handle that. Right? Eight, 16, 24, 32, 46. Ask if it's equal to 0. So we've now filtered. Both chunks would report having duplicates, but in between there are 14 unique characters. Thanks, Noodle. Get some good sleep. Tenny Brio. This is that true? I thought I designed around that, but let's see if that's true. I think this logic is fine in that case. Right? The situation would be repeat 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, BB. So that's 12. So it'd have to be. There's actually only. So this combo. There should be 14 in here. The example I'm thinking of, you have two chunks, A and that BB, where all under are unique. But you can't have 14 characters in there, can you? Right? This. I'm copying literally what you pasted. That's 12 characters, though. Oh, but you're saying that this is a unique A and this is a unique B. But those are unique inside of here, but not here and here. Yeah. So in this case, I think that's true. AA. Okay. I think I have the info to deal with this. Shift right, that. Shift that, shift here. I think I have that from these masks. Right? 1, 2, 3, 4, 5, 6, 7. That and this. Okay, you're gonna hate this, but I think this fixes it. That. Well, I'm checking for equal to 0, so I'd have to change the equality here a bit. But I think if I don't allow the bottom bit to participate in the skipping, then it's okay. Right? What are we doing? We're doing optimization of the Advent of Code Day 6 Part 2 challenge, which has been fun. People are asking if I could optimize one, and now we're deep in the rabbit hole. Really deep in the rabbit hole. I want to learn to build my own OS. It's definitely not easy, but you can just kind of hop into it. Ideally, find like OS Dev wiki is a pretty good form and reference. It's kind of tough. There's not great documentation on getting into it. You just kind of got to get into it, unfortunately. Do you agree this would work, Tenny Brio? I think this would work. Not specifically this, not this mask. This is not the correct logic, to be honest. But something like this, where basically I accumulate all of the bytes positions that have detected a match in front of them. And basically, I will not allow the 0th byte to participate in the hot path. Basically, this of like, it is impossible, then I could just foop around there, right? So like the current logic here is that if there are any matches in an 8-byte period, I skip it. Obviously, that can be wrong because 14 bytes can fit inside of that. Dev Angels, the advent of code today, it's pretty straightforward. It's basically, you're given a string, and you have to find, in that string, find the first sequence of 14 unique characters. That's it. That's it. It's not a hard programming problem. We're making it into a hard problem. So BB or AA gets checked even though they're duplicates. Yeah. Correct. Because I have that information already computed now. Right? That information is contained here. Because this will tell me this is a bit mask for all bytes, which bytes have a forward match. Right? So if I were to just print that and we just skip all this shit. And I think the shift right logical, we are assuming that this is the character set, which is what we have observed from all samples, which is a bold move. We are assuming that is the character set, which means that when we shift in zeros by using logical shifts, we will prevent matches. That's how we're preventing look behind, which to me is important because we don't want to match on something behind us, if that makes sense, right? So we have the original chunk. We're looking at 8 pairs of 8-byte things as 64-bit things. We shift it to the left because the first byte, the 0th byte of the array, is the bottom byte on Little Endian. So in this case, we shift right, which is, we're basically shifting itself over itself, looking for a match in the 7 different positions, shifting in zeros, right? Does that make sense? So like, basically the point of the shift is we have, this is our character set. So let's just say we have these 8 characters or some shit. Is that 8? Oh, no, not even close. 8. Okay. So we have that chunk is equal to this. Specifically, there's 8 of these that we're doing in pairs. But let's say the chunk is that. That means R1 will be equal to C, D, F, G, H, J, L. That, where the underscore never matches, right? 2, 3, 4, 5, 6, 7. Right? So we're doing this. This is the logic. So we have the original chunk. We then generate these shifts. And this is the bottom byte because these are 64-bit. So this is like how it is in data. So this is like array is B, C, D, blah, blah, blah. And we are shifting to the right, and it's confusing because we're shifting it to the left here. But that's because in memory, this is actually, we're looking at the like memory ordering of the array. In which case, we load up the 64-bit int. We shift it by 8. And then we're comparing down the line for all of these, right? And then this mask is doing those comparisons. And since we're shifting in zeros, and zero is not in our character set, we will never detect a match on a 0, if that makes sense, right? So, this, when we compute this, we'll compare the chunk against all of these in all positions, which means that each corresponding bit in the result, because here we're comparing epi 8s. Yeah, so this will end up with a bit mask, right? And this bit mask will then have, if there are any duplicates in here, so in this case it'll be 0, 0, 0, right? And it only looks down here. So does L match anything in here? No, right? And go all the way down. Each bit is true if any shift aligns duplicate characters. Yes. I don't think that's pointing out a flaw, right? That's just saying what's happening. That's the intent. I don't think that's a flaw, right? And this, the fact that we're shifting instead of rotating guarantees that we only are looking forwards. Which also means that we can use like bit scans on this to determine where the first location is that there could be a unique sequence and accumulate that. Why is each character 8 bits? That's just the size of a byte and the characters in their inputs. So the problem is this case, and I agree that this is a problem case. And basically, we want to ignore the result of the bottom and the top bit, right? That actually depends. I think we can just ignore the bottom bit. This one. Which would be this A. We don't have to detect BB because I think what we will do is we will, instead of basically when we aren't skipping, we will correctly resolve into the next chunk, I think. If that makes sense. So we'll ignore this slot, only the first slot, which is the least significant bit. As long as you catch any of the two chunks, you will check the other. Yes. Yes. I think this logic checks out. So that means I should skip R7 entirely, right? Because that is only a comparison of something that's going to be ignored anyways. And we can also skip R1. No, we can't skip R1. This bit is unused, but it doesn't matter. There's nothing we can do about that. All right? Skipping R7 would skip A to A. But if there's a match on the first character, we have to go into a slow path anyways. Right? That's what we've decided. Which means that R7 is not actually affecting our fast path. Because R7 would only affect matches of the lowest bit. And the lowest bit is not going to be used for our fast path. Because if we used it for our fast path, we would end up skipping too aggressively. Or we would. Think we just want to mask out the second least bit of the final mask. Wait, what if we punch this out? This specifically. That would prevent the first letter from matching with the second letter. But that's it. Does that work? Where we would intentionally mask that. And all that is one more and on one thing. And that would prevent the AA catastrophe. Thinking about preventing the JL at the end. Those are the last bytes. Those are these bytes. Those are the upper bytes. It's very confusing, I know. We are looking at the memory order here. You would find the BB chunk instead. Which is this. Is that a problem, though? You could just zero the mask bit, but that's actually a loss of information. Because if we punch out this specific bit right here, just by punching that out means that we would be able to fast path in a situation. But if we punch it out at the end of the mask, then this would go into our slow path. If we punch it out here, then we would assume we would basically discredit the ability for the first byte to contribute to the fast path match. Right? Does that make sense? Just the 1 bit on the final mask? Then that would prevent this from getting fast pathed, right? Or you mean just on R1 or a certain layer? Because anything you do on the mask will prevent that specific position from allowing duplicate fast path tracking. Which would be fine. It would just increase the frequency of the slow path. Like, the logic would still work. But I think this is the fastest way to do it. How many combos are there for inputs here? There's 18 bytes. 18 to the 8. 11 billion. Okay, that's not that many. $11 billion. Oh, the 010 in terms of these two. So that would prevent this. A dupe on that. Which would then make this not a problem, because basically we would look behind instead of look ahead. Basically, we would detect this, and then the slow path would check backwards. Whereas my strategy of punching this out would prevent this, and the slow path would be checking forwards. I think both work. Okay, I agree with that. The only concern I have with that is keeping scans forward and linear is kind of important in terms of like prefetch and look ahead. So I kind of always will prefer to catch forwards. I think you have to look both ways anyways. Is that true? Is that true? Donut, thank you so much for the raid. Hell yeah. Hope you had a good time. We are being goofy. We are being real goofy. Think you have to look both ways anyway. Is that true? Is that true? We got a this type beat. Oh, I see what you're saying. Yeah, because this would trigger a slow path. And thus we would have to look behind anyways. Okay. Yeah, then it doesn't really matter. Then we can do it on the final mask. Specifically, that is the 01. technically this. The top bits will never have a match since it's never compared against anything else. The second to the top bits is intentionally masked off to prevent the edge case where is intentionally masked off to prevent the situation where 14 bytes are straddled across the 8-byte boundary. Situation where 14 bytes are straddled across the 8-byte boundary, and that causes yeah. In this case, we need to either ignore matches of the first two characters or the last two characters to prevent a situation, prevents skipping a potential 14-byte unique pattern. Is that communicated well? Example, this. Capital A and capital B are unique to the 14-byte string sequence, but are not unique to their respective 8-byte chunks. Huh? Huh? The top bit will never have a match. Yep, so we just masked that off for explicitness because it literally will never compare against anything. The next one can only match against the top two. And we prevent that from affecting our logic. Much better at SIMD stuff than I'm... No, we've been struggling for 8 hours. What have you been working on? Okay, then... Oh, that's not correct. He's doing the same thing as me? Oh, shit. What was your strategy? What was your SIMD strategy? Okay, so this is not the correct location to mask. We need to blow this up. Because these are byte level masks, and we need to make them bit level masks. And we can change that by going like this. Wait, compare EPI mask? No. No. 5F, yes. Or 3F. There's a faster one now? Oh, yeah, that one. Yeah. 3F, 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 3F. 3F, 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 3F. Does this logic check out? This is fucking disgusting. We could also do it 4 bytes at a time. Does 4 bytes at a time speed this up? Does it really matter to do it 8 bytes at a time? 8 bytes at a time dramatically increases the frequency of detecting duplicates inside the chunks. Because if we did 3 bytes, then it would only have these comparisons. And there's only 3 bytes that could match there, and it's going to be pretty unlikely, I think. I think with their data set, it actually is pretty likely to have a match in 4 bytes. Because it's not random, it's very biased. Okay, so then we generate that mask. We now need to check each of these if they are non-zero. And I don't think there's a great way to check them individually without using AVX again. So that's what we do. Convert the byte match mask into a 128 bits vector. Right? Then compare each 8-bit lane of the 64-bit mask. We zero the top 64 bits of the 128 bits, and they are unused. There's no 8-bit comparison. Compare each 8-bit lane of the 64-bit mask for equality with 0. Generating a new bit mask, which is now effectively the compressed version of mask above, where all 8 adjacent bits are ORed together. Right? We end with OXFF, here. Now each bit represents a chunk, correct. And then let unique is unique and OXFF. This is, we only use 64 bits from the vector, which is now 8 bits of mask. Discard the top bits from the comparison results. Right? Then, at this point, this bit mask now has 1 bit for each 64-bit chunk and is set if no and is set if any sequences that and is set if any repetition which guarantees. At this point, this bit mask now has 1 bit for each 64-bit chunk and is set if any repetition which guarantees a 14-byte unique sequence cannot be in this chunk or something. Oh, yeah. And a bit is set if there were no duplicates. Yes. A bit is set if there were no duplicates in the chunk. It is if there were no forward duplicates in the chunk. This may slightly under-report in the 1, 2, 3, 4, 5, 6 BB case above, which will prevent the 14-byte straddle edge case. This is designed to fail closed and thus fall into the slow path. Yep. Okay. Then check if okay, then if all 8 chunks have no unique, if none of the 8 chunks are unique, skip all 8 at the same time. Right? This is set if there were no duplicates. If duplicates were detected in all 8 chunks, skip all 8 at one time. That's the correct way, right? And a bit is set if there were no forward duplicates. Which means that if it is 0, is that correct? If it is 0, the only way it's 0 is if every single one had a forward duplicate. Or if... Yes. I'm just confusing myself now. I think that is correct, yeah. Bits are set for chunks which are candidates for potential unique sequences. There we go. Clarification. Bits are set for chunks which are candidates for potential unique sequences. So, if there were no potential unique sequences in any of the buckets, skip all chunks. Right? And then here we'll go... Right? And we can just get rid of these prints for now. And then we stop when we get here, which is an early stop right now. This is kind of a an upper bound of what we can get, potentially. Obviously, we're not actually doing the slow path yet, and the slow path is going to be slow-ish. Okay, so we have like a 6.2x potential gain. Obviously, we're going to be dropping that gain more and more as we actually correctly do the slow path. But I'm pretty sure that this should be bulk discarding a significant portion of the input. Right? All right. At this point, so we could just do this crudely. Should at least discard the first half. Yeah, exactly. And I'm going to say LSB, MSB. Just so it's not confusing. Right? This is fucking insane. This is so unnecessary. Oh, I still have the break-in. I still have the break-in. Let's go. Let's get some more averaging. Oh, 520. 524. It actually hurt it. Fuck. And if we just add a little bit more data here, let's see what we get. $507. $507. That's weird. $519. Interesting. Why is there so much variance? 26754. Oh, I don't have much variance. Oh, this one has a lot of variance. So mine has like basically no variance yet. It's not doing shit. And then this one has a fuck ton of variance. Benny's is actually really stable. Why is this one really unstable? Why is this one really unstable? Zenny? What causes this to be unstable? The unstable and skip stuff? I see. Yeah, because Benny's is super stable. I mean, that's within 8 cycles across all runs. Mine is within 2 cycles across all runs. And then this is off by, Jesus, 3,000 cycles? Wild. Okay. All right. Gucci, Gucci, Louis, Louis, Fendi, Fendi, Prada. Fucking Krayshawn, dude. A guilty pleasure. All right, here we go. All right, 26758. Yeah, mine's pretty fucking stable. So is Benny's, even with the lower samples. Yeah, I think I have ASLR disabled or enabled in this kernel right now, which will actually hurt a lot of things. Your solution is fast. It's not done yet. This margin, we could eat into all of this. Like, this margin could all go away when we actually correctly handle this, right? It's really important to understand that we are now looking at the best possible case, assuming that we can handle the slow path instantaneously. So that's all that matters right now. So I know that internally, so I'm not getting hyped about these numbers because I know that it's very easy for us to use up like half of this just to handle the slow path. So let's do the slow path here real quick and see what we can do. I actually think the compare all might be faster. We'll probably implement both. But let's take a look at the code gen quick before we get too carried away. Perfect. So we load all 64 bytes. We handle all these in 7 axes, which is beautiful. That's what you like to see. 2 comparisons at a time. Beautiful. The compiler is correctly doing 2 compares at a time and then merging them. So it's basically like doing a binary tree zip, where instead of like oring each operation, it is correctly doing pairs, zipping them together, and then zipping those into the result. Like pretty obvious, but that's the sort of thing that you would maybe miss writing like handwritten assembly, or would be annoying to continuously maintain in handwritten assembly. Or I'm at the end, then we have to move it into a GPR. We have to move that into a GPR to perform the masking operation, which is an R8. R8 is correctly loaded into a register permanently. So we're not even doing an and against an immediate here. Technically, I could just put that in a mask. Well, here I have to convert it out anyways. Because then I have to move it from a K-mask. So I could do the math in the K-mask, but we can just move it out. Because I don't think there's a way to go K-mask directly into a vector. And I'm very confident there isn't. Then we move that into a register. We do the actual comparison, and this is correctly checking for 0. So it is just checking against itself. It's just anding with itself, doing a test into K0, and then storing that into R10D. And then we're going to... we're testing the bottom byte. So this mask doesn't even happen. It's just doing a byte test. And this is saving into RDX. Honestly, I don't quite know why. R9 is... that's something related to our loop. Okay. And then that's our loop. So then we're looping. Otherwise, we go into here and the upper and get out. So all this code gen looks fine. Like, nothing in here looks off. This is... Other than, like, crazy bit twiddly stuff, I don't really see any major improvements here. We could technically maybe get rid of these K or Q instructions. Let's see what we can do here. KR mask is a 1 cycle cost. And let's see what equal byte is. Okay, and what about a compare mask epi mask? So the comparison we're doing right now is 1 latency, 0.5 reciprocal throughput. And then let's see what mask epi 8 mask is. Mask compare epi 8 mask. That is 3 latency, 1 throughput. Which I think is just worse. But technically we could like accumulate... Well, these are all running in parallel, so this is actually better. theoretically, we could go the other way and we can make an inverted mask where the mask like accumulates via anding rather than via oring, and then invert it at the end or do whatever comparisons we need at the end. This is actually faster because it can do all of these comparisons are independent comparisons. None of these are waiting for values to be propagated into these registers. So none of these are actually running on latency. They're just running on throughput. So like, this is actually really good. I actually don't really see anything that I would do differently here. So I'm happy with this. Rest in peace. Okay, so now we need to handle the... we need to handle... whatever the fuck we're doing right now. Okay, so, now... slow path. This is a medium path. Not slow yet. Okay, so we can't skip all 8 chunks safely, but we can potentially skip a few of the first chunks before doing deeper inspection. So let's now see and this is going to be unique. This is first chance. Let's just call this the slow path. If I think it's faster to just go through all the bits. I don't think I want to do a for loop here. Let's just write out one. So what do we want to do? We want to skip chunks where unique is 0. We want to fast forward until we get to unique is equal to 1. Right? That's what we want to do. So we can do that with a bit scan, but I think since we might do multiple, since we have to handle all the potential cases in this chunk, because we're not coming back to this chunk, we need to just fucking go for it, I think. Hopefully we don't throw all of our perf away. But I think we're about to throw all our perf away, chat. Maybe not. Maybe not. Maybe not. Maybe we're getting too upset for no reason. For bit pass in 0 to 8. Chunk unique is equal to unique shift bit pass is not equal to 0. Go through each chunk in order. Compute if the chunk was detected as unique. I think this is the fastest way to do this, unfortunately. Hopefully the compiler will unroll this for us. Yes, you can do like leading zeros and trailing zeros, but from my experience, For things like that are this small, like an 8-bit fucking thing, it's going to be significantly slower to keep calling an expensive opcode like bitscan than to just go through each bit. Just because we spent like 4 hours fucking around with this, I'm not gonna re-explain what we did right now, but I'll re-explain it when this works. Is bitscan really that expensive? Bitscan forward is latency 3, throughput 1. And something like a shift and mask is going to be literally like fucking 0.25 throughput, 1 cycle latency. So it's yeah, latency 3. Yeah, they're not free. Okay. Let's just do this quick. Unique. Let's just see what this looks like, roughly. Yep. So we have a bit there. And what this is going to do is we're going to skip 4 chunks, and we're going to be on the 5th chunk. And let's see how deep we are. So we need to technically track chunk ID. Iter enumerate. Beautiful. Okay, and now we can say, if the chunk is not unique, continue. And then this is going to be chunk ID is equal to, offset is equal to chunk ID times 64 plus bit position times 8. Compute bytes offset of the chunk, which has a potential unique situation. Let's see how deep we are. Yeah, we're already at 1952. Let's go! Let's go! Okay, I think we're gonna be good then. That's beautiful. So how far do we have to go back? What's the furthest we have to possibly go back? Come on. How far back do we have to go? I think we have a lot of information here. We can go back extra far and just play it safe. But that's gonna ass. Right? That's kind of ass. I'm gonna give that ass out of 10. I think we have to go back 1 chunk. I think we can go back less than 1 chunk. I do agree that if we go back 1 chunk, I think we are always correct. We also technically have some information from this mask up here. We could just not clobber the mask, and we could know this information. This one we could actually bit scan. Right? Because we still have this mask. And I can use this mask. Honestly, extracting this out of the XMM is the ZMM is probably going to be more expensive than just recomputing it. Let's just temporarily go back one chunk. Now we have the actual fucking challenge. Now all we have to do is solve the challenge. But this is interesting because we actually don't want to solve the challenge for throughput. We want to solve the challenge for latency. Which is way fucking different. Okay. I think the correct logic here is that I get the information from here to determine where it is that the unique sequence started. Do I have that info here? Yes, I do. I can bit scan reverse. Basically what I want to do is I want to get the... I want to look backwards in the chunk. In this. So bit scan reverse in here to go back to the start of it. I want to go as far back as I can where I have not provably found a duplicate. Then I scan forwards as far as I can while it's unique. Oh, but I can't go backwards. This is actually tough. Because I might just be in the middle of a... I might be in the middle of a chunk. Font? Default terminal font. No idea what it is. Someone figured it out at some point. I still don't know what it is. What do I do here? One, two, three, four, five, six, seven. 1, 2, 3, 4, 5, 6, 7. I actually have no idea how to solve this problem. I can do trailing zeros, but how do I then scan for the unique sequence of the previous chunk? I need to find the first byte that could be unique. I need to scan forwards. I can't scan forwards and backwards. I have to pick a starting point or an ending point. But I can't do uniqueness in both directions cheaply. Obviously, you can implement it, but not cheaply. If that makes sense. Right? What do I do, chat? I think D. Perez is correct. I think I understand the code now. Yeah. It's honestly pretty naive. Mask and not that? What the fuck? I can also look for leading and trailing ones and zeros. I think all of those are options. Oh, do I only have trailing zeros? Oh, I have trailing ones, trailing zeros, leading ones, leading zeros. I can do all four of those. So I have to go back a chunk. I'm really starting to struggle. I'm struggling to just think through this shit. Okay, so we don't have the... We want raw mask data. We want pre-clobbered as well, right? We want the original mask before we mask it off. Would it be too slow to just run one of the simpler solutions over bytes starting at the chunk before the first detection? So just go 8 bytes behind? Yeah, we could maybe save like a couple iterations there. I think we're going to be hitting this slow path for most of the last half of the input. So that's the biggest problem. Is we've really just skipped past stuff. We haven't really used the vectorization to get us anything. Chat, I think we're going to vectorize this. We'll start just going back 8 bytes. We technically have some information, but I think it might be pretty expensive to get it. I think what we're going to do is we now have the offset into the payload that we're about to inspect. And I think I'm just going to load a 16-bit fucking, or a 16-byte value, and I'm just going to scan it. This is day 6. All right? I'm gonna do an unaligned load, unaligned 16 byte load. I'm gonna discard the top 2 bytes, and I'm gonna do the same fucking shift thing I do up here, where I just shift all positions, compare against equality, get 1 mask at the end, and it's unique if there's no equality in any of them. I think that's gonna be way faster than like tracking the start and end, maybe. There's a lot of reduplicated work there. All of these regs are dead, and these regs are dead. So I have all my regs available right now. And I can hide. We still have the shifted lanes. I don't think these help. Because these have zeros padded in them. And you can't really cast inside of these. Shuffling's pretty expensive. It's gonna be cheaper to just refetch it, I'm pretty sure. Let's just try it. Let's try this. This is an ass implementation. We have to go 0 to 16, right? Because we went back 8, so we're gonna go through the last chunk and the current chunk. And we'll scan 14 forwards. I'm trying to make this constant time, basically. That's the dream here. Constant time with early exits. Load FU. Doesn't really matter how I load. Try this. Load double quad word. Double quad word, I think, is what that is. This should be latency 6, half reciprocal throughput. And this, it will probably be able to just get it from the load buffer, to be honest. And then this is gonna be inputs, offsets, input.0 offsets, offset plus 16. So we intentionally do the bounds check there. Page. Probably violating some aliasing shit here now. Read a 16-byte chunk. Okay. What bit of the mask is closest to the next chunk, LSB or MSB? The MSB. The MSB is next to the LSB of the next chunk. This is the in-memory layout. It's little endian. Read a 16-byte chunk. Mask off the top 2 bytes. We don't. We're looking for 14-byte sequences, right? Looking for 14-byte sequences. So, I have no idea how to do this. Nice. We can do this. This is so Chad. This is so Chad. Top bits ORed. Is that 14? 8, 12, 13, 14. Yes. I love K masks. And the fact that I can do this is ridiculous. Bam. We just do a mask load. We do a reg to reg. A reg to reg where we mask off the top 2 bytes. Mwah. Fucking Mamma Mia pasta right there. If you have the mask of the previous chunk, which I may or may not, it's possible that I don't have it. But I could detect if I don't have it. Start at index 16 minus that of the previous chunk. I think I would have to recompute this equality thing now. No. No, I would, yeah. I think that sounds right to me. That would allow me to skip up to 8 iterations. Up to 8 iterations. Inclusive of 8 as well. If no bit is set in the previous chunk, I keep getting like the inversion stuck in my head, so I'm not 100% sure. MM SRLI Epi Oh, I can do it on the whole fucking thing. Which is actually what I have to do. Check. 8. I could arguably just do this in a loop. Same with the one above, actually. Eight in that. And then I'm going to compare against that. If I see any matches, I just bail immediately and go to the next. Quadratic in terms of window size? I'm pretty sure, yeah. Really? 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 Oh, I actually want to do rotating this. And I want to rotate... Oh, do I have to do all 16 rotations? I think I might have to do all 16 rotations. Is that accurate? Hmm. I think there might be a byte rotate, actually. Hmm. 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 shit. I don't think I have a rotate. Hmm. Seriously? What font are you using? I have no idea. Uh. Uh. Mom. Damn, VBMI adds some dank instructions. Damn. Wow. Permute X bar? That's fucking crazy. There's some cool fucking instructions in here. Um, is there no way to permute epi8? God, I wish I could use permute X bar. That's disgusting. I thought I saw an 8-byte rotate, but maybe I'm just crazy. Hmm. Why do I feel like I saw a rotate earlier? For the whole thing. Like an 8-byte rotate. Feels bad, man. Okay, so what do I do? Ugh. Oh, this sucks. Hmm. Okay, we'll have to do a shift right. And a shift left, I guess. Hmm. Let's see if we just get something made out of this. So if we shift what's the correct way? How do you do a fucking rotate? Shift, I want to shift to the right. Um and then you do 1 minus it? So it'd be 15? Am I dumb? That a rotate? That's not a rotate. That is a rotate. I did a rotate. I'm so fucking good at programming. Okay. Ah, fuck. I gotta OR those. I'm just gonna assume that this is the instruction. Hey, OR. Nice. It exists! Yay! We did math. Okay, that should be a rotate right 8, right? Right? Is that what that is? Is this good? Is this good? Let's see what we get. Quick question. What do you think about AI taking over programming, like ChatGPT? You tell the program what to do, it gives you the code and guidelines on how it worked. Like, would it affect the demand for software engineers? Yeah, I think we're moving in that direction. And oh wait, what is it? Oh, this shifts by number of bytes. Oh. Oh, okay. I don't know. I think it will definitely affect some more basic programming sort of things. Um, I'm not too concerned about it. Like, I don't know. I just think there's a lot of code out there that doesn't really require that much crazy engineering and design, and I think a lot of boilerplate stuff can be replaced. That being said, I don't think those boilerplatey jobs are necessarily like should exist. That's not shitting on it's companies produce so much code so fast that it's kind of the meta to just churn out shitty code, and that's the sort of stuff that I think really is a pretty big threat of like bots right now, which is just like churning out the same shit that everyone else has done. You're not doing anything new. You're not really even bolting things together in a new configuration. You're literally doing like identical things to thousands and thousands of examples on the internet. Yeah, I think those sorts of things. I don't think those whole jobs will get automated, but I think a lot of that workflow will get automated. That being said, I would argue you probably aren't doing necessarily the best things if that sort of thing is super relevant. But unfortunately, the world is just built of like it's more about rushing code out the door and just producing and adding a bunch of features and getting shit shipped and not really thinking about like the system and how things work together and how to design things that are designed for your system. And instead, it's like bolting on massive warts onto other massive warts without really taking only the cells that you actually need with that code, which is the sort of stuff that I specialize in. I'm not really concerned about AI replacing me before there's like fucking general AI. I think it's just really unlikely. The knowledge that I have is too niche, and probably 80+% of the work I do does not have examples on the internet. So there's no training data that can exist without them, like, until they're consulting me and they're like, hey, can you train our AI for us? It just doesn't have the relevant knowledge to the stuff I want to do. Doesn't mean it's not impressive. It's just like AI, in the current sense of AI, in basically all fields and all domains, is really only going to replace things that thousands of people are doing, and there's hundreds of examples that exist out there. They don't necessarily have to be on the internet. They have to be in some form that can be learned from, whether that can be like data that can be easily obtained through some sort of sensor network, you know, driving cars through cities and scanning stuff or taking photos of things. But ultimately, like, the knowledge and things that I work on aren't documented anywhere. So they're not being trained on. And this sort of AI right now, even like AlphaGo, which to me is really impressive in terms of coming up with like new strategies, a lot of times they're not actually coming up with new strategies. They're just using old strategies to a depth that humans cannot really run in their head, which works great for when problems are bounded by like how much state space you can keep in your head. But in a lot of situations, in like a lot of researchy fields, and a lot of like hard engineering fields, it's not really about applying existing logic and strategies, but deeper. It's coming up with new strategies. Like, it's cool to use it for automating mundane tasks, yeah. And let's be honest, like 80% of fucking programmers pretty much only do mundane things. That's not because that's all they're capable of doing. That's not because that's all they want to do. It's because that's what is incentivized financially, that's incentivized from whatever probably leadership is pushing. It's just, I don't know. Programmers just gluing shit together, dude. Like, it's not meant to belittle anyone who can be replaced by AI. There's a lot of shit that needs to get done. There's a lot of things that, like, a lot of people just aren't incentivized to change and do things dramatically differently, and I'm not in the same way either. I still think what you call general AI is coming, and coming pretty soon, and it won't need to train from you. It'll get the same result given the same request as you. Yeah, I mean, I would love to see that. It's gonna suck for the people who don't control it. It's probably going to lead to a absolutely astronomical wealth gap. The likes of which probably has never been seen before. As much as people want to say, like, oh, general AI, that's great. We can have robots and machines do all the shitty work and everything. No. Like, you're not gonna live in a utopia because these bots are doing shit. The people who have control of them are going to live in a fucking utopia because they're gonna be able to produce things for basically fucking free and not give a shit about how you have to get the money to get them. Like, I know that's the dream. I know the dream is like, oh, we're all equals. The bots will just make everything for everyone, and everyone can get everything that everyone wants. That's not how it's gonna fucking work. If you came up with the technology to make that shit, you're probably not donating it. So, best we can hope for is that AI is just so easy that it's not going to be something you can really keep proprietary, right? Like, that's honestly where I kind of see it. Let's be honest, like, it doesn't really look particularly difficult to accomplish. Not saying it's not fucking hard to innovate it and expand that field, but once it's kind of done, I really don't think the public is going to lag much behind. Like, open source shit is going to lag much behind. And I think a lot of it is just raw compute. Raw compute data sets and the ability to store massive amounts of data. And I doubt any of these AIs yet are even pushing $1 billion+ worth of compute. And if AI is genuinely changing the world because it's like general intelligence and can do crazy fucking shit, you can get a bunch of plebes together and pull together a couple $1 billion and build a fucking supercomputer and make your own models if you need to. Like, I don't think the technology, the data sets are arguably semi-hard to obtain. But the actual, like, underlying technology, yeah, people have slight optimizations and advancements in hardware here or there, but that doesn't really, in my opinion, it gives you a couple year advantage, but Moore's Law is still kind of fighting against you. Good luck outbidding big tech and getting compute from NVIDIA. Yeah, I mean, it's a hard problem. It's definitely not easy. But I don't know. I also don't actually have that high of hopes of AI. I really don't. Like, ChatGPT, impressive. I don't know. To me, it just doesn't really faze me. I don't know. I also have extremely high standards for, like, basically, like, ChatGPT looks like the sort of shit that can pass big tech interviews. And, like, that sounds really impressive because those are great exclusive jobs. But the way you get those jobs is by parroting shit. By doing things in, like, conventional ways, regurgitating things, and, like, doing things. And that's what current gen of AI is fucking fantastic at doing. Not gonna disagree with that. But I don't know. I'm just like not really that worried about. I'm not super impressed yet. Like, I think the most impressive thing to me was AlphaGo. I watched all those live, and that was when I was like, oh shit, okay, it can do like new things. Like chess stuff was not really impressive to me because once again, that was kind of an example of basic strategy run deep. Like, I don't even think like Deep Blue stuff was really even considered AI. And that was running on such a tiny amount of fucking compute. Like, a lot of that was like algorithms and strategies that were well documented, like chess engine style strategies. Um, Deep Blue is tree search stuff. Yeah. No neural networks. Yeah. Chess was about compute power. Yeah. And I think AI is as well, to be honest. Um, I don't know. I mean, I'd love to be wrong. I'd love for AI to be some crazy fucking thing because while I have no experience doing any AI shit, I'm pretty good at optimization and learning. And I'm pretty sure if there's a demand for people to do really fucking bespoke dev and engineering, I probably would be pretty fucking good at it. Um, at some point, I would have to jump on that ship. Eventually, it will just sail too far past me. I think right now I still could catch up pretty fast and be very relevant in the AI world and industry. Um, I don't know. The Chat GPT stuff is just kind of what I view AI to be. Like, I personally, I think AI has like de facto limitations that we kind of just ignore when we look at the results, and we just have different standards for AI in terms of like I feel like we extrapolated a lot more than where it is. That being said, it can have a way wider range of knowledge than I would say any individual can have, and data and resources, and we don't really know what that means, right? Personally, my view is a lot of shallow doesn't necessarily get you depth in any way. But maybe it does. Like, maybe the fact that you have such a wide domain of knowledge, you can come up with solutions that people who are domain specific couldn't think of because they're so stuck in their domain. I don't know. It's pretty hard to say. Probably give it a few more months or years since it's AI. It's going to continuously learn. I'm thinking in the future, maybe like a company of 10K employees right now might be replaced by 100 people because of AI in the future. I mean, I'm pretty sure you can just do that with a lot of fucking companies in general. Like, let's be honest. I've gone on those rants so many times, but the reason companies get big is because managers and bosses get paid based on the number of people below them, so they come up with reasons to hire people below them. And they just grow big enough that, like, you stop realizing why you have so many fucking people. And also, those people are directly incentivized to spend their entire time justifying why they have a team that large and how important their impact is. And a lot of that explanation is just pulled out of your ass. And all you do is you schmooze with the person above you, pull shit out of your ass so that the person above you has enough ammo to defend you without spending too much effort defending you. Congratulations. You're doing great. Like but I don't know. I mean, like, why not replace middle management people with AI? I don't know. It's a hard job. Hey, Party Dip, how's it going? We don't use the S word around here. Okay, so let's actually do rotate left 1. This by 13. Right? That's not how anything works. Is it cheaper to do a 14-byte rotate, which is more expensive to do, or just do a 16 and just ignore things? I think a 16 and just ignore things. I think. Right? But that's a rotate, right? This is a rotate right. I believe that is the case. Yes. Okay. So let's just do a rotate. Rotate. Rotate right. Val. This is an M128i, I think. You have an M128i. Let me just do this. Right. So we have to do all 16 here. Cringe. Oh, fuck. I can't do that, can I? I gotta do this. How do I do that? How does it instrument that? What does it do for that? I'm really curious what Rust syntax that is. Can you do that? Can you say const? You can do that now? Oh. No. No. It's just the way the documentation put it. Okay. Huh. Alright, that's what I thought. And let's see what instruction this generates, and it proves to me how fucking dumb I am. And that you could just do this whole fucking time. This is when I find out I just don't know how computers work. Can't capture. Yeah, Val. Jesus. I'm struggling right now. Mount. What? Can I put it in curly boppers? Son of a bitch. Okay, we can do this. Yeah, take that, Rust. Now you look like a real bitch. Are you fucking kidding me right now? Now I look like a bitch. You fucking serious right now, Rust? You piece of shit. We'll just add it to the whole list here. No problem. No fucking problem. Generic const experts? Fuck yeah. Add it to the list. It's incomplete. Don't give a shit. What? Aren't there like cons blocks or some shit now? Mm-hmm. 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 Can you just not do this? Is this just not a thing you can fucking do? There's gotta be a way. There's gotta be a way to do math. I can make this a macro. Fuck. I'll just make it a macro. Fucking unbelievably cringe. Yeah, fuck you, Rust. Get fucked. Piece of shit. Garbage language. We did it. We did it. Okay, we did a rotation. And that was a rotation to the right. Correct. Because I went bip and came around that way and then blip. We did it. We did a rotate right. Clap it up, chat. Clap it up. Clap it for the rotate. Good. Good, 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 good. Okay, we'll do B01. We're just gonna do 16 of these. I don't actually know if this is gonna be fast. We're just gonna try it and see if it's good. If it's shit, then it's shit, and then we'll give up, and then we'll do something else. How does that sound? Okay, we do some rotations. Now, compute all 15 rotations. Okay, and then we do the comparisons, which is the same shit we did up here, right? Compare epi8 mask. This, compare, this is not 512, and then we'll do a check with B01. Mm-hmm. Mm-hmm. Raise your hand if you think this code's gonna work. Lower your hand if you think this code is garbage. Art. That is art. Fuck. Son of a bitch. Okay. All right. This needs to be 0. Right? This needs to be 0, and it's not 0. Some shit like this, roughly, approximately. That's not good. That's not good. This code doesn't work for shit. What did we do wrong? I should probably add II to offset. Doesn't work for shit. Chunk ID times 64. It'll be 0. So 0, 64. Bit position 0 to 7. That's an 8 byte. Go back 8 bytes. And let's just see. Son of a bitch. Let's just scan forwards really far and see if this works. This is gonna crash. Panic, potentially. Explicit panic. Okay, this shit just doesn't work at all. Okay, good. Page 0 offset. Offset plus 16. Offset added II. Maybe I shouldn't return here. That would maybe be it. Okay. That's not great. One to 15. 6, 7, 8. What? What? I want those prints. Give me this print. O2X. Here we go. What we got? This is saying there's another 62 in here. There is. Saying there's another 6E in here. Or there's not. There's another 74. There is. Oh, this is gonna find the zeros. We have to ignore the top two. The top two will always be set. And this is a 16-byte mask. Does it work now? Does it work now, chat? Hey! It sucks. It doesn't fucking work. It's trash. Trash. Fucking garbage. Slow. Garbage. Shit. It's terrible. It's awful. Rip perf. This is ass, I think, is the problem. I think that's the biggest issue right now, is the assness of this. This is ass. This code sucks, dude. Code's trash. Fuck. How is my code so bad? Does it even get it right? Probably not. It's probably fucking wrong. Oh, break. It is working. Oh my god, is one of these a match at the very end? No, it's not. No, we missed it. We missed it. It's working on the other one, so theoretically, it algorithmically is semi-sound. But it's not sound, I think, is the problem. I think we have a soundness type issue. Let's try this. Let's get rid of our hot path. So, we do everything, but we do this. Always slow path, all the time. Okay, that still fails. Okay, sweet. That means we have a detection failure. Is it due to this? Let's just... Now we're not skipping anything. Now it's just this algo. Okay. So, that is a detection issue. We can look at the perf, but it's going to be complete shite. I think it's going to be cheaper to do this scalar. I don't think it's worth vectorizing this final part here. Which is pretty common for something that's small. When we can't really get up in a rhythm, it's just not going to help us, especially when we're doing unaligned loads like that. Yeah, you can see it's a massive slowdown. Okay, so what we need to do is we need to figure out why this is failing. And the issue here is that we are skipping somewhere. This is the issue. So this unique tracker is causing us to skip over the actual thing. If unique shift bit pos and 1 is not equal to 0. If it's not... Okay, what if we don't do that, but we do this? Really? Okay, something's wrong with this logic then. 16, 24, 32, 40, 48, 56. Compare 1, 2, 3, 4, 5, 6, 7. Compare 8 into the mask, accumulating those on equality. So it's looking for equality between all of these. Do we want to do the opposite of this? Do we want to OR in the top 2 bits? No, I mean, that will unconditionally cause us to search. That's masking the positions where they're found. We are getting rid of detected matches. which will bias towards uniqueness. Top 2 bits cleared. Those are always cleared. So these are the only bits that can prevent us from scanning further. I think the slow pass should just be a version of linear byte by byte code. Yeah, I agree. I agree. But I don't think that's the issue here. I think the issue is we're skipping something. But we can... Well, we know that because if we get rid of the skips, if we get rid of the continues, the unique base continues, then it succeeds all the way through. So our logic is correct. Obviously, the perf is shit of it. But we kind of expected that. So we're skipping things that are contributing. Oh, do I have to go back one chunk? I don't think so. I should only have to go back 8 bytes. I mean, if I go back 64, this will probably just work coincidentally, just due to the shape of the data. But I don't think this is actually correct. Yeah, like that works, but I'm pretty sure that's just a coincidence. I'm pretty sure going 8 back should be fine. Unless we have to go back a whole chunk, but I don't think so. And FF. Okay. I guess we'll just debug it. Sure. Chat GPT read all those comments. Oh, bunch of zeros. Then we get up here. I bet one of these zeros is where it's supposed to be. But that should err it on the side of... Mask is I64. Compare bytes with 0 for unique and FF. Chunk, 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 chunk. What? Three F. That's correct. 3F. 3F, 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 3F. Okay, that looks fine. 8, 16, 24, 32, 40, 48, 56. 1, 2, 3, 4, 5, 6, 7. All coming from chunk. We're shifting right logical. Shifting it over this way. So that's what this is going to look like. And the mask will be set for anything that matches. And then we're going to ignore the top 2 bits. And we're not doing that? Is that true? What's the basic fucking mistake we're making here? We have 16-bit mask, but we use 8. FF. Guess we can print this mask. What dumbass thing am I doing? How is that 0, 0? Oh, they're set. Dupe. And these are on bytes. Oh. So the only way that we can skip here is with zeros. And that's 40. I think this works. The question is the logic flawed? I think we implemented our logic that we intended correctly. Is it due to these gaps? But we should fill closed. We should only skip if we found matches. This is checking for matches. This is showing what has matches ahead of it. We OR those in. That's accumulating. For the bits. So this is telling me which bits in 32-bit words have matches in a spot that we determine is GGWP. Right? Then we mask that down. I think this is wrong. I believe this is correct. This is correctly accumulating in my opinion, this should correctly be accumulating match detection. This part but this only skips if there's easy dupes. Okay, so for lane in 0 to 8, 16, 8. Lane is equal to page.0 offset plus lane times 4, lane times 8, dot offset plus lane times 8 plus 8. That should be getting a lane, right? Okay. I feel like there are probably just better algorithms than this whole algo in the first place. But I kind of want to commit because this should be possible. I don't know if it's necessarily the best performance you can get. I still think there's like a 2x improvement from just a better algorithm. I don't quite understand how yet. But let's keep looking at this. So what we should be able to do is we should be able to assert that there are no forward-looking dupes for this chunk. Right? Slice is equal to lane dot off. So this is like hypothetically going through and showing the remaining components here. So these should all be 8 bytes in length. Everything should be in bounds and just fine. And this is showing like what we're comparing forward, right? This is effectively this table. Right? And the logic is we are comparing, we're looking for a duplicate on, wait, is this correct? Yes. Wait. No, this is right. Okay. Initial is equal to lane 0. For bytes in lane, this is gross, I know. Assert byte is not equal to initial. That should be our logic. That should be literally what we implemented, right? Okay. And this can happen on the cases where we have the masked off shit. So shit got masked off here. We skip. This comparison. The top comparison doesn't matter. So we skip the last two comparisons. Right? This is the logic that we're implementing. Okay, that seems to be an issue then. Right? Hey, Buff Siegel, how are you doing today? Get some good sleep? Jesus Christ, I've been sleeming for a while. Moose! Good to see you, Moosey. The Moosey Bopper. Le Moose. Oh, what did I do? I built this? Okay, so this state should be impossible. What? What? For each lane, offset plus lane times 8. For each offset. What? Hello? Are we dumb, chat? Uh, 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 okay, let's take a look, see what our chunk looks like. How fucking dumb are we, chat? How dumb are we possibly right now? I swear to God, if we're shifting the wrong way, that's going to be embarrassing. It would appear we are not shifting the wrong way. Wait, is that a different failure? 72726C? Or is that the same one we've been seeing every time? I think it's fine. Where is that in here? Seventy-two, 6C. So it's that. 1, 2, 3, 4. 1, 2, 3, 4. We then compare that against this. 72. Is 72 equal to 72? I would allege yes. Is my mask backwards? I don't think so. We'll save off the pre-mask mask. Pre-under mask? No, perfect. Oh, it's from this way. Okay. I mean, that's fucking set. That's set. That... It found a match. Okay. I can't wait to figure out what very obvious mistake this is. Okay. And then we convert this into a mask. What is the mask after convert? We can look at this as O2X. Simmed. This should be a... We're treating this as a U8 for 16. Zero, 9, 2B, 1, 2, 25, 16, 1B, 2C. None of those should be equal to 0. What? What? And then this mask should be... Let's do O16B on unique. Hello? Okay. I'm doing something dumb here. How the fuck is that 0? What? How are those 0? What? Is this a compiler bug? Compare? Oh, I want to actually just have this. Yeah, I just want this. I just want this logic here. Wait. Oh, I actually want to do the opposite of this. I want to detect a match. Yeah, I'm barking up the wrong tree like an idiot. We want to prove that all of these do have collisions. Hmm? 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 What? Do I not know how computers work? Slice unused? Monkas? Wow, I really fucked that one up, didn't I? That was clean. Clean coding. Clean coding. Uh, sure, buddy. Mm-hmm. Mm. Let's just start with this for now. Oh, this will just be wrong, though. Okay. So then this is the shit we're slicing off. This will panic. Okay. What happened here? This is what... This is... Am I doing this logic wrong now? The collision is with the end. And we should be ignoring that match. Well, we should be failing closed on that match. Which I think we are, because we... Those two bits should get masked off. Okay, this is good. We are obtaining information. Oh. Let's look at pre-mask. I have no idea where I am, so I have to shift pre-mask by our lane times 8. This means the bottom bits of the bit slice will be relevant to us. Oops. Okay. I'm gonna shift by 8. Okay. How did we have a unique 0 type state? O8B. Unique. I feel like it has to be a logical flaw. Oh yeah, it's gonna be 0. We know it's gonna be 0. Insertion filled collide is true. I think this is actually fucked. 3, 7, 6, 67, 4. I think this is detecting a problem. Our logic should ignore the last 2 bytes, correct? These 2 bytes should be ignored from our comparison. Are there any collisions in here? No. There's no duplicates in here. right? There's no duplicates in there. But we detected duplicate on it. What's the name of your OS? It's called Sushi Roll. Forward, 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 forward. Okay. This seems like an actual issue. We are saying to discard something when it could be unique. Right? And that's bad. That's a no-no. That's big wrong, big bad, big bad. Okay. Now let's take a look-see. This is bad. This is not good. This is bad. Let's look at the chunk. And then B1, I think, is what we call them. Like B1. R1. 2, 3, 4, 5, 6, 7. Six two six three. So it looks like this. 6263. Oh, that's a different one. Six. Wait. Oh, I just didn't highlight enough. I would say that is where we are. And we found a collision on 0, 1, 2. 0, 1, 2. And that would make sense. 67, it's finding the other 67. Which is... Are we looking at pre-mask or mask? We're looking at pre-mask. But that's not going to get masked off. The mask thing is wrong. 626366766. Simi7, thank you so much for the 3 months. Hell yeah. Yeah, something is wrong with this. Our mask is wrong. Should be the bottom two? No, because this is not that. Hope you have a nice holiday. Hell yeah, thank you. DioCap, thank you so much for the Twitch Prime. I'm excited for the holidays. It's going to be a fun holiday season. 60636667. 0, 1, 2, 3, 4, 5. Okay, so we are on. Yeah, because that. Yeah, of course that bit's gonna be set. Ah. It's because the bit is getting set in a different spot. No. Wait, it is. Oh, okay. I think I see the problem. Wait, do I? Do I not see the problem? Um, the third bit is getting set. I think I need to rotate the mask while I do the comparisons. Right? Right? Am I dumb? Do I not know how computers work again? R1, R2. Mask. It's setting that bit. That becomes 6, 7 at this stage. And that's how that bit gets set. Because the original thing is not moving. Do I need to do compares from the perspective of the R's? I think that's the problem, right? Because that 6, 7 lines up here, and that leads to that bit being set. Should we just zero out the top 2 bytes of the chunk? Yeah, I think we have to bink them up here. I think that's what I was talking about earlier, where you have to delete them here. You can't delete them. You have to remove them here. You can't remove them at the mask stage. I think that's the problem. So I think what I have to do is OR in some shit. Intentionally OR into the chunk. Like FF. Up here. Is that fine? Is that okay? Is that rational? Come on. Give me the dubski. Fuck. Wait, does this have the same problem? Yes. Wait. Yeah, I mean, why would that have changed anything? I need to do the masks on each layer. Because the position of the last two things changes. Oh, I think if I just do this before, it might fix it. Which is what I meant to do. No. Different failure now. Different failure now. And I think we still want to clear the top two. Is that true? So in this case, we're matching on the top one on a 6662. Probably that. Okay, and we're matching on the top. Yep, because the F slides into range. So then we put the old mask in. We need that. We need this mask. And then we need this. There we go. That fixes it. Okay. And it looks like it's successful on all of them, which makes sense to me. Let's turn off the checks temporarily. Obviously, our shit's slow because it's shit, but passes all the tests. And this is going to be a slowdown, probably a 0.2x. Even worse. I think we are now checking a lot more stuff, potentially. Let's see what happens if we just return none here. So let's just assume that we terminate there. How much slower is our initial pass now? Okay, well, that's instant. Really? What? How? How is that optimized out? Okay. Okay, we're still fast. I think we can correctly do this. We can go back 8, right? I think we just go back 8 and we fucking shoot it. And we'll use the fastest implementation, Zenny. And this will be the page offset. Oops. Up to the next chunk plus 8, which is offset plus 64 plus 16. Zenny. Oop, this can't handle misses. I woke up, did some work, flew across the country for a meeting, and came back, and you're still streaming? Hell yeah. So this can go out of bounds. This assumes it will always find it. We can just do input len minus 14, right? Or minus 13? Minus 13 correct here? Or is it minus 14? I'm not really thinking anymore. I'm just doing things. I think 13 is correct in this case. And then I know I have issues down here. Mm-hmm. Smaller of the two. Let's do that filter now. Perf loss. Just because of the slow path. I mean, we can cheat. And we can just do... Oh, what am I doing? Still a slowdown. Not too surprised. I doubt it's even right, to be honest. It's right. So it seems to be working, but it's just slow as shit. Do we need the 4i in? For bitpath? Not necessarily. I mean, we can just do return Zenny 14 page.0 chunk ID times 64 dot map x plus chunk ID times 64. Right? Like, theoretically, we should be able to just do this. That's slower? Really? Why, though? Yep, that's not fair. Oh, I guess things are getting optimized out, maybe? Let's just do this. What? Let's try a Benny here. Okay, Zenny has some really weird performance properties that I don't quite understand. Okay. Wait, why are we doing plus 64? Shouldn't this be 16? It should be plus 24. Because we went back one. So we include the one behind us, the current one, and the one after it. Yeah, and just doing it conditionally is more expensive. We also need Benny to have an early exit. All of these are implemented assuming they're gonna find a match. And I think that's the main problem, is all of these are designed around matches. Benny should exit early when it finds a match, but it doesn't exit early when it doesn't find a match, because it isn't designed to give up when it doesn't find a match within 10 bytes. Arguably with Windows, it does, I guess. But yeah, we could also try a conditional Benny on current chunk minus 8 chunk ID times 64 plus 64 plus 8. You have an index-based version? I might. I'm not sure. Wow. I have a 25% speed up for Zenny. Okay. So yeah, I mean, I'm not really happy until we double the perf. I don't know if I like this algo. I almost am tempted to use 4 bytes. I feel like there's got to be better ways to do this. I mean, we kind of just dove into this and we've been just committing to this, but we haven't really taken a step back and thought about whether or not this is just a good design in the first place, which honestly, I think it might not be. Let's see. I think this ends up just going to Benny basically every fucking time. I think once we get past that first stage, we basically always go to the slow path. So I think we either need to leverage more information that we have such that we can more precisely scan. Hmm. Hmm. What if we did... What if we got rid of those 2 ands? I think we can find the location in this path. Like, I think we can track like how many more remaining bits for each thing. We can track like the location where we found it, or store the mask and do that scan. We have to look into the next chunk. Basically, right now we are we carry over no state. And I think if we carry over state from the last chunk, I think if we make this stateful, I have no way to compare locally. Oh, it's an index-based one? I do think we could just vectorize an algorithm like this nearly directly. Worse, there. And let's try it on just the remainder with a hard exit. Seems kind of worse than Benny. Could also be that there's a dynamic length in there, although that probably will get inlined correctly. Hmm. Yeah, we really need a stronger hint. $11 hours late, Sag. Hell yeah. Thank you so much for the 14 months. I think I need to shift in bytes here so I can more aggressively skip. Right now, I'm not skipping aggressively enough because these last few bytes aren't... The odds of a collision is very low, which means that I am not skipping things. I need to increase the frequency I skip, or I need to hold more data to basically bookend more aggressively so I can make a much smarter, more aggressive, like, final 14-byte search. I think there's a lot of room for improvement here. Because if I shifted in from another word, I think that'd be huge. The MSB of the mask of the previous chunk is 1 before the start of where to check. Yeah, but I have too many false positives. I'm invoking the slow logic too frequently. The time it takes for me to determine, like, to get that information, by the time I, like, extract the bit, do a bit scan for, like, I have to figure out which chunk triggered it. I then have to extract that information from the full original mask information. Then I have to... I guess, is this already a 64-bit mask? The problem is I'm just invoking this too often, right? That's literally the crux of the problem, is I'm just invoking this too often. And the only way that I can prevent that is, I think even reducing the range that I give it doesn't help all too much because I'm paying an initial spin up. I have a latency issue, not a throughput issue. And that's why Benny is faster when I just give the rest of it to Benny. So I, like, help it skip the first stuff early when I am good at skipping it. But then when it gets to the second half of the data and there's just, the collisions are more sparse, I'm not benefiting in finding those because I'm really, yeah, I'm looking for, like, the first couple I have a pretty good chance of detecting if there's dupes. But for the, like, last ones, I'm just running out of information to compare against. So I just end up not filtering much on the back half, and it ends up that the